you to all the participants. One second.
Thank you, ma'am.
I request Vaishnavi ma'am to read the profile of eminent speaker of today's session.
Good morning, ma'am. Good morning, ma'am.
Good morning.
I'm very happy to introduce you today, ma'am.
Thank you. It's my pleasure also.
Okay. Dr. Urvashi P. Shukla ma'am is at present serving as Assistant Professor in Department of Computer Science at Banastali Vidyapeeth. She received her bachelor's degree in Electronics and Communication Engineering in the year 2009. She completed her ME in the year 2013 undergrad Gujarat Technological University on compressive sensing. Dr. Urvashi ma'am received PhD from MNIT Jaipur on hyperspectral image analysis using social spider optimization technique. She has published papers in peer-reviewed journals and international conferences. Her research interests are remote sensing, meta-heuristic optimization algorithm, medical science processing, and data mining. Welcome to welcome you today, ma'am.
Thank you. Thank you so much. So I think I can start the session.
Yes, ma'am.
Yes, ma'am. Thank you so much, ma'am, for accepting our invitation. So sincere thanks to
Ma'am,
you
you're also
and for your
welcome.
valuable time you are spending with us with your gracious presence, ma'am. Thank you, ma'am.
Thank you, ma'am. Uh, uh, is it okay if I stop sharing my video, right? I think that is already done, right?
Yeah, ma'am.
Yeah, okay. Thank you. So I think my slides are visible and we can
Yes,
start.
ma'am. Yeah, ma'am. Yeah.
Okay. So a very good morning to the participants as well as the organizers. And I think that thank you for providing me this opportunity to be getting associated with you people. Uh, so I think that we can start. The whole, I think the concept which this program has brought about, it's optimization in communication engineering. So uh, as I went through the schedule, I have gone through a lot of things in the optimization phase. Maybe the starting mechanisms, multi-objectives, single objectives, the mathematics behind that, and even the previous two lectures that you have gone through are in the same line of actions that what we are going to discuss today. Through differential, even PSO, right? So what we are going to do is we are going to go into the two other categories of the meta-heuristic algorithm. But these, what you will see is they are more towards this PSO othering principle, right? So these are the swarm techniques. So in this 1.5 hour lecture, what we are going to go through is two algorithms, and both are on the swarm behavior. Okay, and we will see that how.
Number இருக்குங்களா சார்
Right.
அங்கே சரிங்க சார் சரி ஹஸ்பண்ட்
Okay, so in this, what we are going to carry forward is your social spider and gray wolf optimization, right? So let's begin. I'll not take much time to introduce you to these techniques, but yes, I'll spend a few seconds to make you aware like what we are discussing, why we need to discuss this. First of all, that whatever topics that you have gone through are heuristic in nature, right? Heuristic techniques actually gives you solution which is near to optimal, right? If you look at the theory or the beginning of these algorithms that came into the principles or the working arena, they were just because you know what, your normal gradient algorithms could not find a solution to the problem. Why? Were not that it was not that they were not able to, but they took a lot of time to achieve that answer, right? So the solution was that we find a method that is giving you near optimal solution, but they should be able to give you within short interval of time. And this problem was solved using the meta-heuristic algorithms. Now you'll find that meta-heuristic algorithms are coming into a lot of categories. Even they are discrete and continuous. When I say it's discrete, it can be binary, right? And continuous, you can have a real and the whole value numbering, right? These are normally considered to be a guided way of searching a solution, right? When I say a guided way means you will always tell your solution to move towards a better one, right? So that is why we say it's a guided approach, right? And today what we are going to discuss is only the swarm intelligence technique, right? When I say it's a swarm intelligence technique swarm means a group, right? So there will be actions which a group is going to decide for you, not as an individual, right? Also, as there is a word of intelligence introduced, intelligence will help you to guide the process, right? So that is why that comes in. And obviously, we are trying to solve any problem or find a solution, a potential solution, but a optimal one, right? So you cannot say pinpointedly, okay, this is the perfect solution that you get. Or I cannot say that if two or three people are doing the same problem and each one of you are getting a solution, like for example, I'm getting 10, someone is getting 10.79, someone is getting 10.59. So I cannot say they all or their approaches are wrong. They all are right, and they're giving me a solution which is near to the expected one, right? Okay, so let's begin with the first one. The first one that we're going to discuss today is a social spider algorithm, right? Now, it's, see, the name is very well expressing itself. It is social, right? So when anyone, in humans also, when we are social, right? So what do? We meet other people, we talk to other peoples, we have a normal life sort, right? So same, the spider is also going to have this sort of behavior, okay? This concept or this algorithm was introduced by Cruves and Eric in 2014. They came up with this ideology because they saw this behavior in the jungles of the Africa. Okay, and here what the principle is going to be very simple. I'm going to divide my whole population, right? When I say population swarm, so I'll take the example that for example, we'll take example like of Sinex, right? So if my problem is to get the solution for Sinex, right? And you can take a range of from between to 0 to pi, okay? So I want my problem that I want to maximize, find the value at which my sine wave gets its maximum value. So we know it's pi by 2, that you get a 1, right? Sorry, pi by 4, right? So what will be my potential solutions of the population? Population will be all the values of x between 0 to pi, right? So you can take all the values of x between 0 to pi, right? Inclusive bracket where both of them can also be a solution, right? This is the problem, right? So first step will be to decide how many population I want or how many spiders I want. So I will tell, let me have 10 spiders, okay? I'm going to have 10 spiders, that means 10x values. Take them randomly, right? Because the first rule of any of the meta heuristic says that, okay, you can initialize the population randomly, right? Not always, but mostly, right? So you can have that x value between 0 to pi. Okay, so for example, the 10 people who are there, someone has taken 0.5, 0.7, 0.10, 1.4 or something like that. Okay, so all 10 values are with me, right? Now the next step that comes is, whenever it's a swarm, right? So each one has to play its role, right? If you see the birds also moving, you might have seen the birds moving. They move always either in this fashion or this fashion, right? So there is a curvature, right? No one moves in a single line, like the ants move differently, right? So there is always a movement that is peculiar to that particular species, right? So same way, spiders also have some peculiar behavior. Here the peculiar behavior is that we are going to have three agents, right? I think that you might have gone through till now. There is something like EE balance always in any of the heuristic algorithms. Now, what is an EE balance? EE balance says has to be someone who is going to explore for you and someone who is going to exploit for you, right? Now, why do you need a balance? Balance is needed because, for example, if there is a room that I'm in, I want to find a safety pin, maybe a pin or maybe a button or something like that in that room. I have two options, right? I jump and cover each corner of the room, right? And I might get that button or the pin. That is exploring the whole space to find a solution. That's your button. Next way can be, if I don't get the answer in my exploring, right, of covering that whole space, that means there is the button which is still there in that space, but it has you have skipped that, right? You skipped the solution on the search space. So I exploit, right? So what will I do? I will go slowly and search at every space with minute detailing, right? So that is exploiting. Same logic comes in your these kinds of algorithms, right? So any of the algorithm will always tell you that these are the agents who is going to explore for you. These are the agents who is going to do exploiting for you. So here also in Social Spider, we have three groups that are working for us. Okay. So the first group is the females, right? And the second is the group of male, right? So, the spiders are very opposite to humans. They have a society which is female dominated. Okay, so you'll find that 60% of the spider population is full of females only. There are other theories also, like that after mating, or sometimes if the food scarcity is there, then males are actually eaten up by females for the survival. Okay, so that theories are also there. So that in that case you will find that only remaining 30 to 20% population of the total is considered to be as male. In that also male, they have two categories, dominated males and non-dominated males. Okay, so they bifurcate males into two categories: dominant males and non-dominant males. I'll give you a simple example. Why do we do, and why it is there? In our society also, there is a sort of these kinds of figures you can find. There are few males, you might come across. Okay, they have money, they have attractions like Hrithik Roshan or something like that. And there are the other males like non-dominated population, where they live a normal life, right? They might be having not so much of money, not so much of fame or something like that, right? So there is always a sort of bifurcation in that sense. Here also the same logic applies, but here the bifurcation is done based on the weight of the spider, right? So they say that if the spider is having more weight, he comes into the category of the dominant males, right? And dominant males get all the attention in the society, right? That is how it is guided. So this is a simple graphical representation to tell you that, okay, what is the population, how it goes. So you can see that you have a dominant male group, right? Non-dominant male group and the female group. Okay. Now, the next thing that we also do is the communication, right? Because communication is how you get your information flow, right? So here, three kinds of communications are there, right? First communication is the best has to communicate. Now we know that this is guided process, right? So best has to tell others. We also do something like this, right? We look at the people who we find pioneer more, maybe like Vivekanand or Gandhi ji or something like. These are the people who guide our sort of journey, right? Maybe any of your own. Same way, the best person here in the spider is going to guide your process, right? So he will tell others that what is the information that I need to pass on to search the solution, right? So in the example of sin x, whoever values of x are fetching you a value which is like 0.8, 0.7, 1, nearby 1, are going to be considered as the best solutions. Okay, their positions, right? Then the second communication, which is there, this is the best communication from the best ones. So now if you see this, the factor which is added in the communication is you have a weight, right? Weight of the person who is communicating to that, right? And then there is a exponential decay with respect to the distance. Now the reason for this is because you are communicating on the web, right? Web actually is made of there's a sort of material, it's an elastic material which comes from the saliva, and when you tap that, it actually generates an oscillatory motion, right? So it is an oscillatory motion on the tap, and it goes and decays over the time with the distance, right? So that is the reason why factor e raised to minus d, distance difference is there. And as the tap, the first surge obviously will be more for a person who is having more weight, right? So that is why it is multiplied with a weight factor, right? Same way, the second communication is between a person who is best but nearest to me, right? For example, maybe my role model in my family, for me, the world is small, right? So for me, my role model, maybe my brother, my father or something. So the person who is best around me and nearest to me, right? So he's also he's also going to guide my life, right? Same way, if there are 10 solutions and 4 solutions are in the corner, so for that corner, the best solution will be who is reaching towards the major solution, right? And the last is the communication with the females. Now, the reason for this communication with females is because you have to generate new solutions, right? For example, I started with the 10 values of X. Now I need more values of X, because it might be possible that in that 10 values of X, I never got the value which was nearer to 1. So I need more solutions, right? How will you get more solutions? By other modes of generating the new solutions. One of the mode of generating the new solution is considered to be mating process. Mating is considered to be right? So for that you need females. So the communication with females is obviously important. Right? Now, here the question comes. Okay, let us complete this and then we'll consider this. Now comes the movement, right? Now, what is the movement? The movement will be actually the movement of the solution from 0 to towards 1, right? That means you have to get the values of X in with respect to sin X to move from 0 to 1, right? So how will they move? They will move when your factors are moving, right? Your solution space is moving. That solution space movement is considered in spider with help of the agent movements, right? So the first movement that is there because of the female. Now, this is very normal that females are very moody, right? So here also the same logic applies. The females are then always the females, right? So in this case, what happens is the females, because of their mood, either they are always in communication with the other people in the group, or they shun away and stay away. Right? So this is what kind of behavior is observed in their life cycle. So that has been brought mathematically by taking that either solution space moves forward direction or the backward direction, right? In the pictorial format, right? Or vector format. So that movement is guided by the PF factor, right? So that is one thing. You select randomly PF factor because certain the behavior or the mood of the females cannot be on the exact scale, right? So that is why. Now, if you see this equation, there are many factors that you have already studied. Okay. The first factor, if you see, I obviously consider the person whose movement is to be considered. So let us consider that we are talking about the first value of X, right? So what am I adding to that? I'm adding the communication with the local best. Yeah.
Ma'am, your first slide is only visible, ma'am. The slides is not changing.
Okay.
Share your entire screen, ma'am. Yeah, now it's okay.
But I think Okay, just a second, hold on. Is it
Okay.
visible now, ma'am?
Now it's visible,
Is
ma'am.
the change
Female
visible?
cooperate. Change again,
Okay, yeah.
it's not visible.
Is it visible now?
Only that female cooperative operators are visible, ma'am.
So maybe,
Ma'am, you share entire screen.
yeah, okay, I'll do that. Is it visible, ma'am?
Yeah, ma'am.
The change is visible. That has to be the more important one.
Yeah, ma'am.
Okay. Shall I continue?
Yes, ma'am. Sure.
Okay. Thank you. So sorry for the inconvenience at my side. Okay, so I think that we can continue. Now I was talking about the movement, right? So if you see this movement, this is the person whom we are considering. Then the factor which is added to is the local best, right? So you get the information from the local person and you add the information. Then you get the information from the global best, you add the information, and then you have a certain random factor. Um, Now, global best and local best, yes, we need the information because it's a guided search. We always want to move towards the maximum or our goal. This random factor uh, is always added. Why? Because normally what happens, if there is a multi-model problem, right? When I say it's a multi-model, means you have continuous peaks, right? Maxima and minima peaks. It might happen that your solution might get stuck into something known as the local minima problem, right? So for that, you need a certain random value to be associated with the change so that if it gets stuck into that local minima problem, the solution will be brought outside, right? So this is the reason why always a certain random values are added at the end of these movements. And this behavior you will see till the all the agents in the all the algorithms normally. Okay. Then comes your change of the movement with respect to dominant males, right? So here what you see is the behavior of the dominant male is guided always with respect to the female perspective, right? Because dominant males are the population that is for mating, right? Okay, so in that case, you see that they have their original position, and the second guiding population will be the female movement, and the last, the random factor, as usual, for the introduction, right? And the third movement is your non-dominated movement, right? So before going to the non-dominant movement, I will say that explorer part, right? Exploring part of the algorithm is taken care by the females and the dominant males, right? So now we want some agents whose movement is going to be explorative. So for that case, you have the non-dominant movement. So if you see that their equation, they are having the movement which is guided by the weighted mean of the dominant male. So when the value is something like a weighted mean, it's a very small value. That means their change in movement is very small. So you are actually asking them that please go slowly, increase your value slowly, and so you might find a solution. So they are doing the explorative part for your algorithm, right? So I think there is a balance. Two agents are doing exploring, and one agent is doing the exploiting part. Next come is how do you find a new solution in the existing population? So for finding the new population, we need a mating process, right? So here in Social Spider, they have used the tournament selection, right? So they have a population. Here what happens is a male comes into the contact. It may be the mating with one male, two male, okay, and they find a new solution, or a small baby spider comes into the picture. The baby spider is introduced into the swarm only in the case if he is a potential solution better than the existing pool, right? That means if you have a new solution that is generated is zero point 0.3, and all the solutions which are existing in the pool are greater than zero point 0.3, then we discard that new solution also, right? So anything which is better than the existing, you are in, else we discard the solution, right? So the same procedure is followed in here also, right? So there. Now, what I could say that what advantages that you come across or the disadvantage for applying social spider are like, for it's easy to understand, right? You can implement easily. You have a PSO resemblance. The success that PSO has witnessed, we all know. We are quite acquainted with PSO working, right? Yes, there is a good balance of exploration and exploiting that is there. See, achievable optimal solution has been found both in the continuous and discrete in case of social spider. But some of the disadvantages of this algorithm are there. That is time complexity. Why I would like to tell you is that because see, if you take that my population size will be 20, right? So 20 as social spider again dividing into three agents will not give you much space, right? Also, it won't bring that balance, right? So for that you need a huge population size. Approximately 50 around is required minimum, right, for this algorithm to work. So if you're trying with 50 population size and then you are doing all these steps for any of the solution, you will have to have some space for time complexity, right? It is I could not say that social spider is applicable to all problem, right? So you have to actually mine out which problems can be really solved by this algorithm. And also, as I have been working in this algorithm, so what I feel is that the role of the non-dominant males can be still more mathematically improved. It is quite underrated, and certain features still can be added so that more application areas can be opened, right? So with this we end the first algorithm discussion. If you want, we can take a 5 minutes question session, or otherwise I can continue with the next algorithm.
Participants, anybody are having any doubts, you can unmute and talk.
Okay, I see.
Yeah, ma'am, you can proceed, ma'am.
Okay, so I'll continue rather than taking
Yeah,
over.
ma'am.
Yeah,
Yes.
okay. So the next algorithm is the gray wolf optimization. Now, this is again a swarm technique only. The gray wolf is considered, it's a hierarchy based, right? So there in the social spider, what we saw was that you divided the population based on certain characteristics, right? Being female or male or weight, right? So here what we do is we take a hierarchy, right? So there are the people, there are certain wolves who is going to be the topmost pack, then you will follow on with the next, and so on. This algorithm was proposed by Mirzali in 2014, right? So he considered the wolves as apex of predators, right? So wolf are considered to be like the most species that they hunt, and they have a very great hunting skills, right? And they are the top in the food chain also, right? So uh, they have a lot of skills with them, and that is how it is there. Normally what they have found is behavior of wolf, they live in a group, right? Because as it is a swarm or a group pack techniques, and on an average you have one group with something around 5 to 12 members on an average, right? So, and they have a very strict social dominant hierarchy. So there are three terms that has been continuously introduced. A strict means they all follow to and adhere to rules. Social, because they are living in group, they are not working as an individual. And again, dominant because there will be certain wolves who are having higher authority compared to the other wolves that are residing in the same colony. So this is what is the social hierarchy that you will find in wolf techniques. So there is something like alpha, beta, delta, and omega. Same as what we saw in your social spider, like female, male, they have four categories. That is your alpha, beta, delta, and omega. So we'll study characteristics of each group, and we'll connect to how the solution can be found in the same case. Now, the first level is your alpha, right? Alpha here are considered to be the dominant wolf. They have all the responsibilities of hunting, and they are considered to be as leaders, right? And so they will be followed by the other wolves in that group, right? So actually, what you can say is that they are the global solution. In the same aspect that we went for sin x. So if there is some solution which is coming as zero point 0.8, zero point 0.9, so those solutions who are giving you zero point 0.8 and zero point 0.9, their corresponding x value will become the alpha wolves, right? So they will be the solution who will help other falling solutions also to reach further ahead, right? So this is how the wolf are doing, right? So in that leaders, the alpha can be male as well as female. They have wholesome responsibilities of like making decision when to hunt, how to hunt, how many people will be there in the hunting, what is the time that we need to reciprocate, what is the time that we need to go for hunting, how many hunting are to be taken in today's time, right? So all those decisions that will be taken by these pack, okay, this group, I would say. Okay, they are in a dictatorship position, and all have to follow them. Okay. Then comes your next level is your beta group. Beta are the subordinate wolves. Now, why would I say subordinate wolves? Because this group actually will take the decisions um on the behalf, right? On the behalf of the alpha group. Now, what is happening here is that, for example, if there is some alpha wolves are injured, right? Or some alpha wolves have become ill, so who will be there, who will be aiding to them? The next as it is in hierarchy, so if the king is not present, who will be the other king? Whoever is the member of that family, right? So that is how the hierarchy is passed on, that same way here the beta group has all the they are the best people who can be taken ahead to become the alpha wolf, and they help the alpha to, like, for marking the density, marking your area of work, or how would you go ahead. And they will be directing, they take the position of the alpha, right? And they also have to communicate whatever the decision of the alpha to down the lane, right? So they have to communicate to delta as well as omega group, to take the decisions, help them. Okay, you have to move in this area, you cannot go here. So this all will be taken care by the beta. Third is the delta, right? Now if you see that the third level are also is also sometimes called as subordinates, but their work is divided into certain categories, right? So normally there are different groups that will be there in your delta, right? And they always have to work as per the directions given by the upper groups, and they will be doing that work and communicating back to that hierarchy like alpha and beta, but they will be more dominated to the omega, obviously, right? So what are the responsibilities that is given to the delta are, like, for example, the first is scouting, right? So what is a scouting? They have to watch the boundaries, they have to safeguard the territories, right? There is a, if there is some danger or there's some warning values, they detect it early, informed to the alpha and beta group. So the scouts are always from the delta. Then it's celestial wolves. Celestial wolves are always responsible for protecting the pack, right? For example, we also have soldiers. So that is how the celestials are also working in the same direction. Then there are elderly suggestions that comes. So elderly people who give the experience, okay, today's weather maybe, or some problem, health issues, or hunting problem, food in the harsh environmental conditions. So that is also coming from the delta. There are hunters. Hunters will be always hunters are also coming from this delta group. So hunters will be responsible to help uh, hunting alpha and beta, right? Because if the preys are more, they might need more people to hunt for them, and so how it hunters go. The last is the responsibilities of the caretaker. Caretaker comes into the picture not only for the weak, ill, wounded, but also for the small wolves who are there. So they have to be taken care when the other wolves are the alpha are at hunting positions. Then there has to be some wolves who take care at the back end. So these are the caretakers. So with this, all the five duties that are there, that is consigning only to the delta group, right? So till now we have seen three groups. That is the alpha, mostly the top of the hierarchy. Then second is your beta, and the third delta, and the last that we'll be talking about is the omega. Now, omega are considered to be as scapegoats in the pack. So they do not they do not take any decisions on themselves. They do not have any right in the their wolf pack, right? So their role is something that they always have to work as per the down the information. And you will see that, they are not the role that they play is not considered to be as important as an individual, right? And they are also allowed to eat only after the upper hierarchy has been completing with their food, right? So this is the narrowing down. Now again, we need to find who is going to be the explorer part and who is going to be the exploiting part. So explorer part here will be played by your alpha and the beta group, right? Because they are the most active people in the group, right? So their movement is very fast as compared to the delta and the omega, which is paying up. So here the exploring part is burdened on the alpha and the beta, and the exploiting part is taken care of by the delta and omega. Why? Because their role is low, so their movement is less. So finding a solution in the space slowly will be taken care by these two groups, right? Now the social hierarchy, right? So whoever is the fittest solution, or whoever is nearer to the optimal solution, will become the alpha. Then so on. That means you will sort your population, right? You will always sort the population based on the fitness. um, Whoever is the fittest wolf will become the top of the hierarchy. So whoever is the fittest solution in your case for finding an optimal solution will become the top solution, right? For example, sine x value of 1.13 will give you pi by 4, right? So pi by 6 is giving you some nearer answer. So that value will become the top of the population that you have taken, right? And then you keep on ascending order, right? So you keep on taking up one by one the solution, and you consider the whole solution. The rest, whichever cell, for example, you have taken 20 solutions, then you sort them, right? So last solutions, right? The first, second, and third, that will become alpha, beta, and delta, and the rest will play the role of the omega, right? Now the hunting, right? So obviously they in your social spider, we talked about the movement, right? So we talked about the movement in the spider web, right? So here the movement is considered on the plane, right? Because your movement is always for the hunting, right? So their main action is hunting. So they have formulated that, okay, our hunting will be based on certain formulas, right? So let us see what is the mathematical formulation done for hunting the prey. Right? So what do? Is they do an encycling process, right? So obviously, if there is some, it as it is seen in the pictures, also it's visible. If there is some animal which they want to hunt for, so they'll make a group around it, and they will try to, create a fear in the other animal that you're now going to be eaten or you're there. So that's an encircling process that is done. So here the behavior of encircling that is there. So what you can see is C into XP minus XT, right? So XP is the position of the prey, right? So with that respect to, the position of each member is going to be calculated. So how much far you are from your prey, right? So that is a distance factor, right? And then because you have to either move towards the prey or away from the prey, right? Obviously there can be only two actions. Either I go for the hunting, either I move away from the hunting, right? So that is why the update in the position is with respect to the XP, right? The position of the prey, and where the position of the prey is minus A into D. Now there are certain factors like C and A. So these are the constants who is going to guide your process, right? So these are the values that you have to take, or sometimes we also take them as a tuning parameters, what you say. So these parameters have to be tuned in, right? So here it's there. So these parameters are given certain names. Okay. So for any of the current iteration, right? So you have your coefficient vectors, right? XP, as I told you, it's a position vector of the prey, and X is the position of the wolf, right? So they have calculated your coefficient vectors, that is A and C, using a formula, right? So A is considered as 2 into R1 minus A. Again, all random positions are there. The reasons for taking these random value is because we don't know which individual wolf is thinking what, right? So how would you take the decisions of the movement in the mathematical formulation? So the best way to emulate them into the real mathematical formulation is using the random values. So that is why these random coefficients are taken, right? But obviously, when you apply them, right, for any of the applications, the values will has to be tuned as per the application, right? For example, if you're using in certain optimization problem of mechanical, right, for some design parameters. Second is for you're using for some seating arrangements, then the values of the A and C, which are taken for both the applications, can never be same, right? Now the encircling process, right? So as we know that hunting is obviously the process which is guided by the alpha, right? Now both alpha is the person who is there in the hunting process, but the two next in the hierarchy, beta and delta, their contribution to the hunting is manifested that okay, they are not always present there, but depending on the demand and the situation, either of them can come into the picture. So here the next thing that comes is we have done the mathematical process of our hunting process, and we know that who are the people who are taking participating in that, and we have also updated the solution as per the moment. So this is the mathematically what you can see here is now the equation initially was shown with respect to was a normal equation where you have the communication between prey and the wolf. The wolf can be from any of the uh, domain, that is he can be alpha, beta and omega. So what they have done is they have taken the role of all the three, right? So d alpha, d beta and d delta, that means distance of the prey with respect to the alpha position, beta wolf position and delta wolf position, and then a cumulative decision of the distance is taken. So which wolf will be moving by which how much distance, is taken care, right? So here what is shown is this is your prey, a radius has been taken, that is R, and the movement, the complete, this is a move, this is your wolf whose movement has to be judged, right? So he will take his movement will be affected by alpha, the beta and the delta, right? So what are we taking? We're taking the same equations, right? But now it's an addition of the 3 and given to the prey. So this is the complete algorithm of your gray wolf optimization, right? So here also we'll do the step one. The what is the normally the step one that is done in any of the algorithm is population or the population and parameter initialization. So first is the size of the population. So I will take 50, 20, 30. We can say here the normally the value of wolf that you will find in the research area is something about 20 to 30 in the range. Okay. Then you have your parameters. So who are the parameters that you need to take care? You have to take care of the A and C, right? Because that A and C were the random movement that guided the hunting process. And the third is the stopping criteria. I think that we haven't discussed in both of them. uh, what is the stopping criteria means, right? For example, I'm doing the sin x problem. Okay, so what are you looking forward for? We are looking forward for a value which is maximum, and I want the value to be 1, right? So what can be my stopping criteria? I can stop when I reach 1, right? That is one thing. For example, after I saw that I reached 1 at 100 iterations, right? But before that also at 99, 97, 98 also it was already 100. So I found that okay, from 50 only it is 1, right? So the next thing can be I can take that maximum iterations. So I'll stop the max after maximum iteration of 1 of 50, right? So this can be the stopping criteria. Other can be the change in the solution, right? You can obviously witness the change that is coming in the solution. For example, as I told you that after 50 there is no change, you are getting 1 only. So what you can see is you can have a window size that okay, after 20 iterations, if there is no change in the optimal value, we can stop the algorithm, right? So that is also there. So there are many criteria which has come about, and the stopping criteria can be decided by the person who is formulating the problem, right? Then is that you start with the first generation. Normally when we talk about this, we talk about the generations, right? So we start with the first population, right? You find the fittest solution, right? Why? Because you have to bifurcate population into alpha, beta, delta and omega. So how are you doing that? That is based on the hierarchy, and hierarchy is guided by whom? The fittest one. Who is the fittest? The solution which is giving you the best answer, right? So you take your fitness function, right? The fitness function, the objective function, whatever you're looking forward for. For example, if you're looking forward the application of image, then your fitness function will be the correlation between the pixel. If you're looking application of any design parameter, then you're looking for a design of a screwdriver with maximum rotations. So you fit in that solution. Okay, is this size is giving you maximum rotations? If no, then you're not considered as a solution, right? So this is how we do the fitness solution as per the application, right? Then comes your bifurcation. You divide those solutions as alpha, beta, and delta, right? Then what is the act here? Here act is of encircling, right? So you keep on doing that encircling, right? So that is what is coming in your solution update, the repeat rule. So you keep that encircling, and as the parameters are there, parameters positions will be updated. Once your positions get updated, obviously your fitness is going to be changing. So for that fitness that you have with you again make a solution listing. Okay, after the change, what is the fitness, right? So then whichever the population is giving you fittest solution, you repeat for the next iteration. Here also you have many methods. See, we have many methods for finding who is the best solution. There are many methods of population replacement, right? So if you'll see that there are many algorithms who consider the population size to be constant over the time, right? So that means you started with 50, you will always be 50 only. You keep on replacing the bad solutions, right, based on the fitness. There are certain methods where population size can be increased, right? So if you're increasing the population size, it's good because you're bringing in new solution space. But with that, you're increasing the time complexity. Right? So there's always a lot of things that has there that the designer has to think, right? Before jumping into any of the working solution, right? So this is how the continuous algorithm is taken care, and whoever is the best solution, that always will be given from the alpha group, right? Because he is the peak of that pack. Now, what are the advantage of this algorithm, right? The gray wolf. First, what I felt is it's a very simple. There is no more mathematical equations. It's very simple. There are only equations of the hunting, and the hunting equations are only the distance minusing. That means you take the simple distance formula, right? So it's the simple structure is very simple. Then because as the structure is simple, if you're applying it for multi-variable or multi-objective sense, right, then the storage requirement is very less because the variables are less to store. Convergence is faster, right? And also uh, if you see compared to the social spider, there is not much things to be done in the right, because their communication is not mathematically modeled. They do not have any other parameters to be introduced in. There is no mating process. But if you see the social spider, there is communication, mating process, even the movement, right? So there's a lot of things that are involved there. Decision variables are less, yes, because you only have to think about two, that is A and C, the coordinated movements, right? And they have to be adjusted. If you make it, the wolf is you working for your application, right? Now, what I would like to spend some few time is on the research gap. What I have always felt, because um, the, if you'll see that today, a lot of publications are coming in this area, but there's a lot of work at present to be done, which is being done is on multi-objective and multi-variable concept, right? So, what as I have felt is that, if you pick any of the algorithm, right? Maybe a spider or a fish one. There are frogs, there are monkeys. There are lot of, like, it's an endless list, right? So what as I being a researcher in this field, what I feel is, what is the reason that there is not so much popularity that what GA and PSO gained, right? Why other algorithms are not making to that? The reason is we are not sure that what is the theoretical foundation or that is there behind it, right? We studied their behavior, we formulated a something mathematically called their movements, and we tried to solve a problem. If you're able to solve, it's good work and you find it. But if you're not able to, we look for another algorithm, right? So you will see that, there is something like free lunch theorem. So you cannot say that my algorithm is going to be the jack card which will work for any application, right? So there is a lot of theoretical background which really needs to be worked upon, that why these algorithms are working, or is it necessary to bringing such algorithms actually, right? Also, people talk about exploring and exploitation as in their algorithm, but there is no formal definition, or what you will find is how it is implemented, what is the level, the depth, or has it been satisfied by that agent or by that group that you're talking about. So it's a little of dilemma, right? So we obviously need really to find out that each of the algorithm which is considered is contributing a well balanced, or I would say a ratio of between these two parameters, the exploration and exploitation, right? Also, the next challenge that has come across is how would you compare, right? You will see a lot of paper that comes into the picture which says, okay, we have compared PSO, we have compared GA, we have compared Wolf algorithm for the same application. But is it a fair comparison? Like, because what you take is, you might take the same platform, right? You might take the same number of population size, but that's not going to give a solution. For example, in GA, you can do the same problem solution with 20 chromosomes, but in case of SSO, it won't happen. You take 20 spiders, that won't give you an answer. You have to take 50 and above that to get the solution. So is it better to invest 30 more and get a solution, or rather sustain with that 20 in GA and work about, right? So these are there, right? Then there is a large scale optimization problems which have never been answered, right? So there's a lot of potential area in the positive side also that you can work here. We also need a lot of methodology that can look forward for, how, if you look at the literature, each step, like for example, I'll take initialization, right? So in initialization, you have a lot of techniques. Now people are coming with more and more techniques, like quantified sampling, surrogate theories. Then they take fuzzy definitions for initialization, right? Rather than picking up randomly, and they say that, okay, we did this because the initial solution was not random, so our convergence is better, right? Yes, accepted, that is true. But is it that your initialization method is going to be fitted into all others? No, we don't have an answer. Second is, how is the mating process? Certain people do it using crossover as NGA, certain are having tournament selection, best selection, other, and this and that. Even selection techniques are also, lot of selections or techniques have come across. So what is the last, at someone working in this field will really feel that, okay, I might have tried this method, I might have got this answer, right? So there's a lot of thing there. And the last thing is that, can really, if the solutions are working good, can other techniques be brought about so that we can have less time consumption? For example, parallel techniques, GPU techniques, uh, right? What is there? Multitasking, multi-threading, or all these techniques can actually be brought about, and we can find a good solution with less time complexity and memory utilization. So this is what I have found, and I would like to thank the participants as well as the organization team for giving me this opportunity. And the last thing from my side is questions or your query time. It would be great to have them. So thank you from my side.
Thank you, ma'am. Participants, anybody are having any doubts, you can unmute and ask. Ma'am, 1 second, can you please switch on your camera so that we can take...
Yes, ma'am. Sure. Yeah, hello.
Yeah.
So all your questions are welcomed. I hope that,
Anybody having any questions? Ma'am, I have one question, ma'am. When I did
yeah,
my
sure, ma'am.
PhD, I used this gray wolf optimization. So nowadays the same channel estimation and all they are doing with the different combination, hybrid combinations of the different algorithms, ma'am. So again, now I feel that there are so many other new techniques are upcoming. So how to decide which algorithm is best for our problem, ma'am?
I think that this is the most difficult question that to come across, because if you'll see that for same thing happened for me also, that I solved the problem of image. My problem was image. So when I started, I
Yeah.
solved it using Social Spider. Right today, if you'll see that there are a lot of publications that has come. Okay, that our algorithm is also working. Our algorithm. So what
Yes.
I feel is you just look into the literature first, right? What is the people telling you? Like, for example, if the GA is working best, right, for channel estimation, you have
Yes.
also applied gray wolf. So at present you just try to thoroughly go through that literature. Okay, some people are telling it, and let us find the solution from that only. Because if someone is saying that, okay, rather than gray wolf genetic is algorithm is working, then we have to first verify what is his working conditions, and what are the conditions in which his algorithm is making good answers, right?
Yeah.
It is completely going to differ, because we are not working on the same system, we are not working on the same working conditions, even our parameters are not same, ma'am, right?
Yes, ma'am.
So you will have to thoroughly go through the literature, what that person is saying, that for him point 7 is giving a good answer. Then you have to find out that why point 7 is giving a good answer for him, and why not for you,
Correct, correct.
right? So
Nowadays,
you
upcoming
go through that.
hybrid algorithms are also coming into picture, ma'am.
Yes, hybrid are also coming. The reason for bringing in hybrid is very simple. For example, I'll take my example only. We can take Grey Wolf also. In Grey Wolf, what they are doing, they are only finding the distance, simple distance, right? You find the distance using another algorithm, any of the hybridization, right? But
Yeah.
you just try to see the two main points in that. The first is that when you're doing hybridization, is your solution moving in the space, right? For example, what happens
Yes.
sometimes that when we try to mix two algorithms, rather than bringing in the solution, we take the solution out,
Correct.
right?
Yes.
For example, if you're doing channel estimation, weight estimation, the weight was supposed to be there within the range of 0 to 1, but your answer is going out of the 1, because you have
Yeah.
mixed two algorithms. Even your initializations you have done wrong, or something has happened. So what I would say is, being at this position, I cannot say that, okay, they are wrong or mine is best. But when it's a process of judging or applying into the application, then you really need to spend some time with these algorithms and find out, okay, if there is some potentially a good papers are there, if even good algorithms are there, you can try them once and check into certain parameters that if they are fitting, it might give you the answer.
Correct. Yeah, sure, sure. Thank you, ma'am. Ma'am, I
Okay.
wholeheartedly thank you for accepting our invitation and I express my gratitude to you, ma'am. Thank you so much. And you explained elaborately, you explained about the social spider algorithm and also the gray wolf optimization. And you explained in a neat manner what is the principle for survival of the fittest. So, for all these biological evolutions. So, thank you so much, ma'am. Thank you for being with us in this FDP. Thank you, ma'am.
Okay, well, welcome.
We'll be in
Okay.
touch with you in our future events also. Thank you, ma'am.
Sure, ma'am. Thank you. Always welcome,
Thank,
ma'am. Have a nice
yeah.
day, and thank you
Thank you, ma'am.
participants also. Yeah, and a
Yeah.
bye from my side, ma'am. Have a
Yeah,
nice.
ma'am.
Thank you. Okay.
Participants, within another 10 minutes, we'll start the next session. Next session is on hands-on experience on how to do whatever the theory we have learned so far. So how to do it by using the online softwares or whatever the toolboxes existing in the platforms. Okay, so we'll start exactly at 11:25. Is that okay? 11:25. Can we start at 11:25?
Very good morning to all the participants. Welcome you to this next session. All of you have been interacting with Padmaja Madam so far. I'd like to take this opportunity to introduce her. The next session is going to be by Dr. C. Padmaja. Dr. C. Padmaja ma'am, working as an assistant professor in the Department of ECE Genetics, Hyderabad. She has received her bachelor's degree in ECE in the year 2002. She has completed her MTech in 2006 from Sri Venkateswara University, Tirupati in Electronics, Instrumentation and Communication Systems, and has received her PhD from JNTU Hyderabad in September 2020 in Channel Estimation using Turbo Code Model for 4G OFDM systems. She has 14 years of teaching experience and 5 years of industrial experience at GE IIC Hyderabad. She has published 6 reputed journal papers and 1 national journal in technology spectrum at JNTUH. She has published 8 international conference papers in IEEE Explore and received 2 Best Paper Awards. She has delivered a talk on MIMO OFDM and channel estimation on 9th April 2019 at SISTEC College of Engineering, Bhopal. Also delivered a talk on Tinkercad during internal FDP at GNITS from March 8th to 10th, 2021. She has received Dr. Sarvepalli Radhakrishnan Best Teacher Award on September 5th, 2021. Her area of research interests are in the field of 5G wireless communication signal subspace estimation techniques, compressed sensing in massive MIMO, machine learning and optimization theory to study real-world systems with stochastic behaviors. I'd now like to invite Dr. Padmaja Madam to take over the session.
Thank you, sir. Yeah, good afternoon, all the participants. I, Dr. C. Padmaja, welcome you all for the 4th day of AICTE ISTE sponsored workshop. And today I'm going to give a brief intro on what are the tools available on open source and how to use them for our optimization techniques. So far till last 3 days we learned about, in the first day we have seen by Dr. Chella Sastry sir what are the analytical skills are required for defining a particular optimization problem. On the next day, second day, by Dr. Rajib sir from IIT Guwahati, we have learned about how to solve that particular problem by using theoretically Newton-Raphson method or row minimization or column minimization, or how to calculate the rank of that particular matrix. So every optimization problem we have to consider it as a mathematical problem, and we have to define that problem in terms of a vectors or matrices. So and we have to try to minimize that particular vector. So by applying whatever we have seen in our engineering background, mathematics, how to solve that particular any matrix, minimize that matrix by applying Newton-Raphson or whatever the techniques we have learned so far. So but today what I want to throw a light on, what are the various online open source softwares available and how to define this practically. So suppose if the particular person, if they don't have the knowledge in software coding, all these mathematical approaches for defining the optimization problem can be done through C, C++, Python, MATLAB, and also even in Java and so on. There are so many other software coders available here. But if the person or the researcher don't have the coding capabilities or the skills, so then how to proceed the research? So there are some open source softwares available. So such as I want to tell you about the 3 softwares. One is we can do our problem solving by means of Excel solver. The other one is GNU Octave, which is a open source platform. The other one is MATLAB. Everyone, any communication engineer is free to use all these open source softwares, right? So let me share my screen first. Is my screen visible?
Yes, ma'am.
Yeah, thank you, sir. So this is our my session is on implementation of Excel solver and MATLAB optimization toolbox. So for doing this, I totally segregated this into 4 parts of my session within this 1.5 hour duration. First of all, I want to introduce you. So far we have learned so many definitions. What is optimization? What are the techniques? And what are the various algorithms till so far, right? So I have to give just 10 minutes what is the introduction of optimization, then we'll go into the Excel solver hands-on experiments will do, and also I would like to introduce you what are the various techniques that we can solve within by using the MATLAB inbuilt optimization toolbox. And also there is another open source platform, that is GNU Octave, which can also we can use for our optimization research. Okay, so the first one, if you go, so this is the first PPT. So this is completely, I want to tell you about what is optimization. Can anyone tell what you understood from last 3 days? What is meant by an optimization? Okay, so the optimization is nothing but it is a mathematical model. So any problem, real world problem, we can, if I want to come to college in a less span of time, so that is my objective. Okay, so what are the constraints involved behind that my objective? So I have to use some solver. In my case, that is a GPS. So I can switch on that GPS and I can verify what is the shortest distance. That is the first constraint. And the second one is that particular shortest distance should be, that particular road is very clear. There should not be ups and downs, right? So I have to check that also, and how best I can reach my college within a less span of time in a busy schedule, right? So that is one example for defining the optimization. So any real world problem can be treated as a mathematical approach. So that definition will call it as a objective function or optimization algorithm. Okay, so and whatever the rules or whatever the impact I want to project it finally, so those impact will call it as a rules. So those are call it as a constraints. So in my example, the constraints are, the particular road should have the speed limit at least 40 kilometers per hour. That might be the first constraint for my optimization problem. And the second one is what is the minimum distance, road, I mean traffic should be less, and these are all the set of constraints I have to make to define my problem, right? So this is call it as a optimization. So before going to that, I would like to tell you what is the history, why we are going nowadays with respect to the optimization algorithms. So various optimization algorithms are there, why we are going for that. So and then what are the main components to define an optimization problem, and what are the basic definitions required to just start the research in the field of optimization, and what are the types of classifications. Coming to the history, from our school days, we know if I want to design any system, I can do it by regarding this experimental design, right? So I'll start with some set of parameters, and I'll start that particular design, and I'll get some sort of the output. If that output is not visible, again what we are going to do, so even in our lab sessions also we are going to try to do that same design of that model again and again and again till you are getting the satisfied result, right? So that satisfied result, we'll call it as a feasible solution. So what is the ultimately, what are the drawbacks of this experimental design? So because we are doing iteratively until we are going to get the final answer, so it is the human involvement is more, and also the time consuming is also more. So because the human involvement is more, that particular setup is also very expensive. So I have to pay the money for all the persons who is involved involving in the system of the design, right? So this is the experimental design. So then come to the simulation design. So nowadays we have seen even the MATLAB also is having some Simulink. So many ECAD lab is also having some simulations, right? So what is the advantage of this? So by introducing this simulation, so I can I can invent the new designs which are fast to get the particular output of that particular design, right? But there is simultaneously there are some drawbacks also. So that is, though there is a medium human involvement, but this is error prone. So something is suppose if I in that simulation environment, without calling or without picking that particular block from the library, if I take one more block, so then it might goes to the error prone, right? So then, so because of in order to avoid these disadvantages, we are going for optimization algorithms. So optimization algorithms perfectly yield to either optimal solution or near optimal solution. I'll tell you what is optimal and near optimal in the coming slides. So we'll get exactly the correct output by satisfying what is my internal constraints. So whatever the example just now I gave you, so that is to deal with to reach my college in less span of time, whatever the constraints I decided, ultimately I have to satisfy all the constraints, then only I'm happy, right? So that is nothing but optimal solution. So but doing with this, we have to follow some set of algorithms. Those algorithms are complex in nature. We have to understand what is that definition, what is the process steps, then only we can start the particular design by using the optimization. Okay, so next, so these are the main components of the optimization problem. So this is our system or this is our model. I want to design such a model. So if I want to design, any system consists of set of inputs, right? And it generates some set of output, right? So and the particular the estimation of the output, if I want some estimation in my mind, I have to apply at the back end some of the rules on my inputs to get the appropriate output. So this is the optimization problem. So what we have to do to get the desired output, I have to apply some of the rules and this impact on my inputs so that I can get what is my output. Right? So these inputs are known as a variables, and whatever the rules I'm calling, these are call it as a constraints, and what is my output of that system, we'll call it as an objective function. So finally, if I want to define any optimization, the framework will be like this. Either we need to minimize the output, the objective function, or we have to maximize this such that we need to satisfy the constraints. So what is the optimization problem? Either we need to minimize this objective function or maximize. So suppose if I give an example like this, suppose for any company, so if I want to start the particular company, so what is my internal constraint is I have to get a good profit out of this, right? So after considering the human involvement and whatever the set of rules I frame, ultimately my intention is I have to get more profit, like Mukesh Ambani, right? So if I want to do like this, so then so I want to maximize the profit, at the same time I want to minimize the human involvement and also minimize the cost of the each product that the company is going to deliver, right? So this is called as an optimization framework. So the framework looks like this. Any problem we have to write in the form of either maximize or minimize the function. So that particular objective function is a function of the input terms. So if the input consists of x1, x2 and so on xn, so these are all called as a inputs to that system, or we'll call it as a variables to that system. So the function of the variables is nothing but my objective function. So these are the main components of my optimization problem. So we'll look into what are the internal definitions that we need to learn before starting the particular research in this area. So the first one is, what is an optimization? So I already told you, optimization is nothing but it is a mathematical tool or mathematical model or algorithm to get optimal solutions. So for that, first we need to know what is meant by variable, right? So I told you already, so inputs are also known as the variables, and this may take different type of variables. Either the input is in the form of a continuous in nature, or it might be in the form of a discrete in nature, or if the input might be in the form of a binary in nature. So for each of this, there is a set of algorithms. Okay, so now, so what is an objective function? Objective function is nothing but the output of that particular system produced by the system, right? So here there are two types of outputs, objective function. Suppose if the system generates only a single output, then the system is called it as single objective optimization. This is a class of optimization. Okay, so how can we define? If the particular system, if the arrow mark comes out of the system is only one, so if the system generates only one output, then we'll call it as a single objective optimization. But say similar to the inputs, if I have more number of arrows coming out of the system, so that is more number of outputs produced by this system, then we'll call it as a multi-objective optimization. So Friday, one of the eminent speaker discussed about the multi-objective optimization, right? So this is the objective function. Objective function is nothing but the output produced by that particular system. So if it only one output produced, then we'll call it as a class, that is single objective optimization class. And if the particular system generates a multiple outputs, so then we'll call it as a multi-objective. So then coming to the constraint. So I already told you what is constraint is nothing but a rules. So what are the different rules? So either that particular rule might be a hard in nature, or that particular rule might be in a soft in nature. So rule hard is nothing but if I'm able to satisfy my constraint, that is, we'll call it as a hard constraint. So means that ultimately at last I have to satisfy all my constraints. So which is call it as a hard constraint. So if in special conditions, so suppose if I can also violate my constraints, then it is lead to soft constraints. And also these constraints are of four types. One is we'll call it as a linear constraint, non-linear constraint, equality constraint, and inequality constraint. So these constraints is like this form. So that particular constraints, if the variables, so where we have to apply these constraints? I have to apply these constraints on my input. So that is variables. So if all that variables lies within a particular limits, so then we'll call it as a bound. If that particular variable lies on the line of a particular system of linear equations like this particular graph, if my variable, all my variables lies on this line, then we'll call it as a linear equality constraint. And if my variable lies either above or below this particular line, optimal line, then we'll call it as a linear inequality. And in similar way, non-linear equality is non-linear curve is like this, exponential either rising or decreasing. So if my variables, all the variables lie on that particular curve, then we'll call it as a non-linear equality. And if the variables lies above or below this particular line, we'll call it as a non-linear inequality. So this is all about this particular constraint. So here we need to know what is meant by search landscape. So means that this is nothing but what is my bounds in the system. So from where to up to where I have to search for my optimal result. So that particular solution, and we'll call it as a search landscape. So here in this we have to learn about what is the type of output we are going to get. So either that particular output might be a feasible output or infeasible output, or it might be an optimal output or a near optimal output. Feasible solution is nothing but if it satisfies all my constraints, then whatever the result, we'll call it as a feasible solution. If it violates, then we'll call it as a infeasible solution. So Optimal is nothing but it is it is obeying all my constraints such that we are getting the maximum profit from that. So then in such a case we'll call it as an optimal solution. Near optimal is approximate to the optimal solution. We'll call it as a near optimal. So these are the basic definition we should know before starting this particular algorithm setup. Okay. So now coming to this particular example. So I've just I've written the framework of the optimization. I want to minimize a function of this particular variables and it generates some output. This is the output subject to, and this is the some equations I have written. So from this I want to know about how many variables do you see in this problem? Can anyone unmute and say? How many variables are there in my definition of optimization problem shown here? Any participant can unmute and tell about how many variables do you see in this problem? How many variables? 5, right? So always any objective function can be written in the form of f of x. So where xi is nothing but how many number of inputs are going into the system. So here I am taking 5 inputs, so which are also call it as 5 variables. So my question is how many variables do you see here is 5 variables. Okay, so the second question is how many constraints do you see in this problem? Constraints are writing only after that particular word, call it as subject to or such that. Okay, so subject to, I have written that x1 is a rule, always it should lie less than 0. x3 is a variable that lies less than 7 and some of these variables should lie less than 17. So these are the some of the rules I decided before going to start this particular definition of my problem. Okay, so how many constraints do you see in this problem? 3 are there. So this is first rule, second rule, and this is the third rule. So now can you guess what type of optimization problem is it? What type of optimization problem? I told you there are 2 types of optimization problem. One is we'll call it as a single objective. The other one we'll call it as a multi-objective. So the definition for this is if the system produces a single output, then we'll call it as a particular class is known as single objective optimization. So if you see here, so x1 plus x2 x2 plus x3 into x5 by x4. So this is a single output that is produced by definition of this particular function, right? So this is single objective constrained optimization. So this is, I'm considering some constraints into my definition, right? Single objective constrained optimization. So this is the answer for the third question. Okay. So now coming to the classification, before going to the classification, we need to know about what is unimodal space and the other one is multimodal space. Unimodal is nothing but if I'm having only one solution, so then it is a unimodal, and if I have the multiple local minimas, so then we'll call it as a multimodal solution, that particular landscape. Okay, so with this we have to know about what are the classification of the algorithms. So this particular classification, there are broadly 2 types. One is the conventional. In the olden days, how they are doing this optimization is by using the gradient descent. So which is nothing but usually defines the maximization problem, and it gives the peak value of that particular statement of that problem. So suppose if I want to get the minimization, I have to apply the negative gradient to get the minimum value, and the response of that gradient descent is like a parabolic shape. So like this.
right? So whenever we want to get the minimization, we have to apply the negative gradient, and the final, this is the particular value where I'm going to get the optimum solution. Okay, but in case of the conventional approach, we'll also call it as a deterministic approach. So we will start any person. So suppose if there is a particular treasure, so if two persons are playing treasure hunt, and if the person hides some treasure in some place and ask the other person to go and search for that, in this particular deterministic, each and every member has to start from the same location, and again he has to come back to the same location. So in this case, every run we will get the same output. But in case of the mode run, we'll also call it as a stochastic approach. So where we can avoid such a local minima. So local minimas are nothing but, so suppose here the person, one of the person in that game starts his search from here, the other person can start his search from here, right? So these are the local optimum values. So but actually what is the final minimization output? So this is the final minimum output. So this is your global optimum value, whereas this will call it as a local minimum. So in case of the mode run, all we are seeing till last 3 days, so all these mode run algorithms avoid this local minima and try to give us what is the global optimization problem. Okay, so this is about the classification, and these are the introduction about the optimization. And coming to all optimization algorithms follow this particular theorem. NFL theorem is nothing but no free lunch. You know, no free lunch is nothing but we are learning so many algorithms, like since from the first day there are so many particle spam. Then we have seen about GA, genetic algorithm. Then we have seen about the evolutionary algorithm, meta heuristic algorithms like bio-inspired algorithms and so on, right? So each and every algorithm is going to get, each and every algorithm going to solve a set of optimization problem, but each particular one cannot solve all the real world problems. So that is called it as a no free lunch theorem. Okay, so all whatever the algorithms we have, all algorithms perform equally in nature. So this is just about the introduction. Any doubts in that? Okay, so we'll move on to the next one, that is Excel solver. Right. So I already told you how to install the Excel solver in your laptops. So there is a different procedure for Windows OS as well as the Mac system. First I'll tell you what is the procedure. Okay, so here for downloading this particular Excel solver, what you have to do here is first go to open any Excel sheet. Open any Excel sheet, go to file, and from there is a last one, we'll call it as options. Click on that, then go to, there will be some window will be popped up. So in that, go to the last but one, that is add-ins. In that, go to the right hand side, you can see this manage option where you can, there is a drop down button, and in that Excel solver will be there, and beside that go button will be there. Click on the go. So once you go, click down that particular one, so you will open again one popped up window. So in that there will be a some sort of this check boxes they will give, like solver add-in. Click on that and then press OK. So this is a particular procedure to use this solver. Okay, so how to use this? Go to Excel. So I'll show you. This is a Excel. So go to File. The last one is Options, and one window will be popped up, and left hand side there is a Add-ins. Click on that, and if you scroll it down, the last one is a Manage, and within that box Excel add-ins are there. Beside that Go button is there. Click on it. Click on it. So there is a checkboxes here. So we want the solver add-in to this Excel sheet. So check that particular checkbox and click on OK. So because already I have installed on my particular system, so it is showing this solver. Where you have to see this solver, go to Data button, and rightmost top corner you can see this solver option. So not in Home. So go to the Data directly. So there, right hand side top corner, you can able to see what is your solver. Okay. So this is a procedure. So we'll move. So this is a installation procedure. Here we will solve some of the linear problems as well as the non-linear problems. Okay, so everybody please do along with me so that you can come to know how to do this, how to define a problem, optimization problem, and also how to do it by using a Excel solver. Okay, so here what is my function written here? Is it visible my screen? Right. So linear programming. So here my function here is, there is a function, a linear equation known as x plus y. I want to maximize this such that it has to follow all my constraints. So these are the constraints. Whenever I am writing something like this, so after this subject to word, these are known as constraints. And I told you constraints might be either equality constraints or inequality constraints. So if you look at this, what are the type of constraints are this? These are all less than or equal to or greater than or equal to, means that these are inequality linear constraints. Okay, so this is the definition of my problem. If I want to solve this, so what we have to do is go to Excel. First, we have to define what is the variables you have. So, what are the variables? One second. System is very slow. Right. Please open Excel and write the variables. What are the variables we have? So, looking at this problem, what are the variables we have? So, I'll just copy this here. So, I'll copy this entire one and paste it on the Excel. First step is we have to side by side. Is it visible now? So now what we have to do is, the first step is you have to define the variables. So what are the variables you have? So you know what is the variable? Variable is nothing but inputs to that particular system. So I'm increasing the size of this. Is it okay? Right. So what are the variables I have? So if I look into this particular function, function is having defined as x plus y. So means that there are two variables. One is x, the other one is I have the another variable y. Right. So these variables I have to give some initial guess of that particular variables. So initially I have to assume some initial values to my variables. Always start with zeros. Okay. So to define your variable values. Okay. So this is the first step. So what is the first step? We have to define what are the variables available. So then we have to define what is your objective function. So what is your objective function? So objective function, I am increasing the font of this. Right. So what is the objective function here? Objective function here is f is equivalent to x plus y. So I have to write my objective function as f. So if I want to write any equation in the Excel, if I write it simply like x plus y, it won't work. It is a something like annotation itself. But if I want to represent it as equation, what I have to do here is I have to first write equal to, then x. So what is x here? So the x and y here acts as a comments here. Whatever the values I am giving initial guess values to that variables, that act as my inputs to that system. So after putting this equal to, according to the definition of my function, I have to select the first one plus, again select the second one, x plus y. So I'll increase and then press enter. Okay. So this is my objective function definition. Okay, because x and y have taken it as a 0, 0, the output f is also 0 plus 0, which is equal to 0. Okay, so this is objective function. So how to define this? So first I'll do it again. So what how to represent a function in Excel? So first I have to write equal to, then I have to select the first one, x plus is a, normally you have to press keyboard plus. So then select the second variable and press enter. You will get a particular output. So the first step is you have to define the variables. The second step is you have to define the particular function. And the third one is you have to define constraints. So what are the constraints in this? The constraints here, there are three constraints here. So the first constraint, let me write it as G1 is the first constraint. Even this is also like a mathematical expression. So how to write any algebraic function here, as we have written for objective function, in the same manner we have to write here also. First I have to write it as equal to, the first constraint is nothing but minus x plus 2y. So I can write this as minus, what is my x here? X is this particular cell D7. So select that. So minus x plus 2y. So 2. While writing any constant, you have to use, don't simply write it as 2 into that particular y cell. So you have to mention that star mark here. So then y, what is the y here? The next D8 cell. So if I press that and then press enter, will give you what is your G1. So that is first constraint. Okay, so but the constraint is having some inequality value, right? So what is that inequality? Less than or equal to, and what is that value you have? So that is 8. Okay, so similarly, I want to define what is my second constraint. Second constraint is equal to, so what is the second constraint? 2 into x plus y. So 2 into 2, put the star mark, into x. What is x? That is D7 cell plus y, that is D8 cell, and then press enter. So this is your G2 expression. Okay, and here also what is the constraint here? It is also less than or equal to, and the value of that particular one is 14. So I am noting down everything in this Excel. Then I will use this solver. So, and similarly I have one more one. So that is 2x minus y less than or equal to 10. So that is I am calling that third constraint as G3, and go to this, and what we have to do? First we have to type the equal to button, then 2 into x minus 1 y, 2 into x. So what is my x? That is D7 cell, 2 into x minus y. So what is y? That is my D8 cell. So then press enter. So you will get this particular value for G3, and this is also less than or equal to, and what is the value for that? That particular value is 10. Okay, and still I have some more bounds on my input variables. So let me call that as G4. So what is that bounds on my input variables? X should be greater than 0 and y should be greater than 0. So I am writing this as G4. What is that? X. So even this is also how to write. First I have to press the equal to, then select the D7, that is my x value, then press enter, and what is the condition I am making? That is greater than or equal to, and what is the value I am having? That is 0. So, and similarly I am stating the condition for my other variable. So here if I want to write, so y should be greater than 0. So how to write? First I have to write equal to, then select the y cell, that is D8, then press enter, and write in the beside that what is the condition? Inequality is greater than or equal to, and that particular value of this is 0. Okay, so this is my constraint, set of constraints I am looking for. Is it visible? Now, so what is my objective? This is my objective. Okay, so objective, this is my function. So which is equal to f is equivalent to x plus y, and these are my variables. So what are my variables? X and y, and I took, these are the initial guesses. So if I want to solve this through Excel solver, so the first we have to write all the 3 steps. If I have any constraints, and then I have to define what is my objective function, then I have to declare what are the variables, and I have to guess initially some guess points to, in order to start my optimization. So if I want to do it, solve it, so where the solver lies? So solver lies in data. So go to data and click on solver button. Okay, so here what is the first one? It is appearing, set the objective. So what is your objective? That cell you have to. So what is the objective? So as I told you already, whatever these variables I have written here without equal to, so those acts as a comments. So I cannot select this particular cell. So which one I have to select? Only where I am keeping that particular objective algebraic expression as a equation. So that is equal to, after equal to, this is the particular cell. So if I click on it, automatically it goes here, that is D14 is my objective function. So what is my definition? What is my intention to do this? I have to maximize this. So what is my definition? That particular function need to maximize. So here there is an option for maximization or minimization of my problem. So click on that maximum, and then I have to select, the next one is what are the changing variables? So inputs are all is nothing but the variables or the changing variables. So where I have to select? I have two variables x and y, but I should not select these two. But if I in the form which I have written after the equal to. So how to do this? So I have to click here and select these two columns. So what are the columns here? D7 and D8. So D7 to D8 are my changing variable cells. So these are the variables. So then I have some constraints in my problem, and this is the below box. We have to enter that particular constraint. So beside that there is an add button. So where we have to write your constraints. So what is the first constraint here? G1. But where I have to select this particular block, I have to select because I kept this as equal to something 2x plus y, right? And what are the condition I have to make here? That inequality is either it is less than or equal to, or equal to equality constraint, or greater than or equal to, and so on. There is a list here, but which one I have to choose? That particular constraint is a less than or equal to. And what is the value it is given as per the definition? 8. So then click on add. And similarly, I have to enter all my constraints. So what is my second constraint? So after G2, after equal to whatever the equation I have written. So that is D21. This is also less than or equal to, and here also I have to give it as 14. Okay. So again, I have to add the another G3. So G3 here is, this is D22. I have to select that less than or equal to, and the value here is 10. Then add. So then I have some constraint on my input variables, that is x and y. So x is nothing but this is a x. What is the constraint on x variable? It should be greater than or equal to, and the value is 0. So then add, and similarly there is a constraint on y variable. So y is here D24, and this is greater than or equal to, and the value here is 0. Right? So once if I enter all the constraints, click on OK. It will appear in that box. So the first one is less than or equal to 8. The second one is less than or equal to 14. The next one is less than or equal to 10. And whatever the variables I have chosen, those values should be lies above the 0. Right? So now coming to this, below of this, there is a system of algorithms to solve by using the Excel solver. There are 3 types. Already I told you this Excel solver is used to solve 2 types of problems. One is linear problem, the other one is non-linear equation problems. Okay, so if you see here, what is the type of problem given here? Function is equal to x plus y. So then it is nothing but it is a simple linear equation, right? So in such a case, I have to select simple LP algorithm to solve my problem. Okay, and here there is a checkbox denoting that what is my result, what is my constraint variables, whether it is non-negative or negative. So all are, these are positive values. So don't change anything here, and then click on solve. A pop-up window will appear, and if you want to see that particular one, within how much time it is solved your problem. So there is a reports here. The first one, click on the answer one and then click on OK. It will give you, this is a report of your problem. So how much time it take to solve this? So here it takes 5 iterations to get the optimal solution, and within, what is the solution time here? That is 0.016 seconds. So suppose if I want to do the same thing theoretically as IIT Professor Rajib sir told in the form of a Newton-Raphson method, it takes obviously minimum 10 to 15 minutes of time. So because it is a simple equation, might be you can solve it within a 10 minutes. Okay, but here by using this Excel solver within 0.016 seconds, so whatever the constraints we have, everything can be solved within the less span of time. That is the main advantage of this solver. So the next thing is, so from this, how many variables x and y? What is initial values I guess here? That is 0 and 0. After that, what is the values? 4 and 6 is the optimum values. And similarly, what are the constraints I took here? What are the initial values? What is the final values? So this is my report after completion of this solver. Okay, so any doubts in this? This is the same procedure we have to follow for any type of problem. So because this is a linear problem, that too a very simple one, and we did like this. So suppose if I have any nonlinear expression, only the change is what is the selection of that particular algorithm. Here for solving this linear problem, I selected the algorithm name is simple LP. Okay, so if I want to do that non-linear type of questions, so then I have to select the GRG non-linear algorithm for solving out my optimization problem. Okay, so this is one thing. So what are the output you got? So that is for x it is 6, for y it is 2. And if I substitute these two values in this equation, then finally I'll get the output as x plus y, which is equal to 8. So this is the value I have seen in the answer report. Okay. So any doubts in this? So we'll go to the another linear programming, that is the maximize f is equal to 45x1 plus 100x2 plus 30x3 plus 50x4 subject to these three constraints. And can you do along with me? Right. So what is my question here is, this is my question. For my sake, I'm copying this in this Excel. This is the question. So what is the first step I have to do? I have to write what are the variables I have in my problem. So let's everybody do this. So how many variables I have here? How many variables I have here? X1, X2, X3, X4, right? So write all this. So X1, below that X2, below that X3, and below that X4. Okay. So these are the variables. So the next step, what we have to do? We have to give initial guesses to all the variables. 0, 0, 0, and the last one is again 0. Right? So this is the first step we have to do. So after looking this particular problem, we have to define what are the variables and we have to allot some of the initial guesses to that. So the next thing what we have to do is we have to define what is your objective function. Okay. So how to define the objective function? I'll increase the font here. This is my objective function. So how to do this? So what is the name of that particular function? F. So I'll write this as F. How to write the equation here? In an Excel sheet, if I want to write this, I have to write first equal to, then 45. And if any constant is there, don't simply just like that write 45 and select the x1. So you have to keep the star, then select the x1. X1 here is, what is that cell? D7 plus again 100 multiplied by x2, which is the D8 cell, and similarly plus 30 multiplied by x3. So this is the x3 and plus 50 multiplied by x4 cell. So this is my, and then press enter simply. Because I took all zeros as my initial. So at first my objective function also produces the output as 0. Okay. So this is the second step we have to do this. So what is the third step? constraints. So how to write the constraints? Looking at this particular question, how many constraints I have? Actually 2 constraints, and bounds on all my input variables is greater than or equal to 0. Okay, so these 4 plus 2, totally 6 constraints I have. So I am defining these constraints, naming to each of the constraint as first one G1, next Z2, next one Z3, next one Z4, next one Z5, and the last one I'm calling it as G6. Okay. Okay. So first what we have to do this, I have to write these expressions in this constraint. So how to write these expressions? So select that particular cell and type equal to, what is the constraint? 7 multiplied by x1. What is my x1? D7 cell. Just keep it like that, plus 10 multiplied by my x2 plus 4 multiplied by my x3 plus 9 multiplied by my x4, and then press enter. So this is my first cell, right? So what I have to do here in the next cell, what is that inequality it is maintaining? Less than or equal to, and what is that value it is maintaining? So that is 1200. Right. So just for I have to define all this in this same manner, and similarly go to the next constraint, which is nothing but how to mention that beside that cell. So select that cell and type equal to, then 3 into x1. What is x1? X1 is the D7 cell in my case, plus 40 multiplied by x2 plus x3 is my D9 cell plus x4 is my D10 cell, then press enter. And what is the inequality it is maintaining? Here also less than or equal to, but the value here is 800. And similarly, what is my next constraint on in my input variables? Input variables, instead of G3, if I make it as X1, I think it's clear all of you, right? So G1, G2 means those are the constraints, and these are X1, X2, and X3 and X4 are my input variable constraints. So what is the constraint I have? So G equal to, select the X1 cell. So that is G7 cell, and then press enter. So which is greater than or equal to, what is the value it is maintaining? Initially that value it should be 0. And similarly, if I want to write the constraint for X2 variable, so select the cell and write first equal to, then select the X2 cell and press enter. So then write it as greater than or equal to, that is the inequality it is maintaining, and the value for that is 0. And similarly go to the X3, and for mentioning the constraint on X3, first write the type equal to, then select the X3 cell and press enter. And what is the constraint here? Greater than or equal to, and the value here is 0. And similarly, the constraint on X4 is equal to, what is X4 here? That is D10 cell, and press enter. And what is the value for this? Constraint inequality is greater than or equal to, and that particular value is 0. Okay, I am increasing the font. So this is my definition by looking what is my optimization problem. First I defined what are the variables and some initial guesses, then objective function, then I defined the constraint. So then how to solve this? The next step is go to data and click on solver. So the earlier one, it is already there. So what you have to do is, delete everyone, the previous values. And now we'll start this. So what is my objective function? So which cell I have to click here? So if I want to mention my objective, the definition in Excel after equal to where I mentioned that particular cell, I have to make it as an objective. So this is my objective function. This is just like comment. Beside that, I defined this function. So select that particular cell. It will automatically appear in this popped up window. So then what is my definition of the problem? I have to maximize. So then click on the maximization. So then I have to add what are my changing cells. Earlier I have only 2 cells, 2 variables in my system design, but here I have 4 variables. Where I have to select? These are comments. So beside that, whatever the definitions I make here, so those I have to select. So at a time you can drag all 4 and leave it. So all will select automatically appear on this window. So from D7 to D10. So that is your changing variables. So then we have to add your constraints. So where are the constraints? I have these are the constraints, right? So what is the first one? So after G1, how you defined your first constraint? This is the first constraint. What is the inequality it is showing? Less than or equal to. And what is the amount it is making? 1200. So then click on add. And similarly, select the second one, less than or equal to, and the particular value is 800. Then add, and constraint on each of the variable is x1 greater than or equal to 0. That is the another constraint. And similarly, x2 greater than or equal to 0. Add, and x3 greater than or equal to 0, and x4, this is this particular cell, right? So greater than or equal to 0, and then press OK. So these are all my constraints automatically appear. So the first one is less than or equal to 1200, next one 800, next one 0, 0, 0, 0 for all my input variables should be greater than 0, right? So then because what type of problem it is? So the problem here is a simple linear equation. So if I want to do this, which algorithm I have to use? Simple LP, right? And click on this particular simple LP, then click on solve. So what it is showing? You are getting the solver found some solution, optimum solution, and there are some reports here. And the first report is answer. Click on OK. It will generate some answer report. So here what type of algorithm you have used? Simplex LP. And what is the solution time? 0.015 seconds, and it took 7 iterations to complete your optimal solution, to reach your optimal solution. And then this is your objective function. Initially I selected this objective cell is 0. At finally that particular value is 9333. Okay, if you want you can round these values also. So similarly variables, I have 4 variables. Initial guess of these variables is all are 0. After completion of my all 7 iterations, these are the updated values, and these values you can also see from that particular sheet. So earlier I have kept it as zeros, right? So once I completed this solver calculation, so these all values are updated automatically. Okay, so what is the final output of this particular function? F is equal to 9333.33. So this is a optimal solution for my linear problem. And for at what input values I am getting this output means, so these are the input values for all my input variables. Okay. So this is a simple, the same procedure we have to follow, whether it is a linear problem or non-linear problem. Okay, so this is a linear constraint problem. So this is the second one. So for all these inputs, what is the function output I'm getting? This is a solution for that particular problem. So this is the second one. Okay. So now nonlinear program. We'll solve one nonlinear programming problem. So then we'll move on to the next one, that is MATLAB. Okay. So if you have any doubts, you can ask, you can unmute and ask meanwhile. So the nonlinear programming is in the form of like this. So minimize f of xy, comma, it should be in the form of squares, cubes or square roots or whatever it is. So it's not like a linear problem. Okay. So I took this particular example, x minus 2 whole square plus y minus 3 whole square, and the search domain here is minus infinity to infinity. All my input variables are lies between minus infinity to infinity. So I told you one definition in the earlier slide, that is search landscape. So this is my landscape, entirely my input variables and its corresponding output objective values lies within this particular bounds. So these are the limits to my variables. Okay. So, and one thing you have to observe that here in this definition of my optimization problem, I did not give any constraints. Okay. So this is the particular definition. We'll also call it as non-linear optimization. That's it. If I mention any constraint, then it is called as constrained non-linear optimization. Okay. So can we do this? So first I am selecting this entire and copying. This is my problem, right? So first I have to write what are my variables. That is the first step. So what are the variables here? How many variables I am having by looking at this particular problem? I am having two variables. One is I am calling it as x. The other one I am calling it as y. So what is the next step we have to do? We have to give some initial guesses to this. And these are not there, right? I am deleting this. Right. So these are my variables. So next is I have to write it as what is my objective function. So what is my objective function? Here it is defined as f of x comma y. Right. So f of x comma, I'm mentioning in small letters. Right. So how to define this function as per the problem. So before writing, the first step you should not forget this. First we have to write equal to, then I have to start defining my problem. So equal to, after that bracket x. So what is that x I have to choose? D7 cell minus 2 bracket, close the bracket, then square it. So for square you have to shift and upper arrow. This is power square 2 plus y. So again open bracket y. What is y? D8 cell you have to select, minus 3, close the bracket and square of that particular function. And if I press enter, this value will be given. Okay. You can check here also. If I keep x and y as 0 and 0, what is the values? 2 square plus 3 square. That value is initial value based on our initial guess. Okay. So now here there is no constraints. I don't require this particular table, right? So this is my simple non-linear problem. Okay, so how to, we'll start doing this. Go to the data and press on this solver. Before that I have to delete all, select each and delete each of the constraint. Select each and delete the each of the constraint. Now we will see. So what type of problem it is? It is a minimization problem. That is the first thing. So select the minimization. And what is my objective cell? So earlier some value it might be there. So what is your objective one? So this is the. So click here and click on this particular cell, automatically appear here. So what are my changing cells? So here I have only two variables and the changing values, drag these two, automatically appear here, D7 to D8, and there are no constraints, leave as it is. And coming to the definition of the algorithm, so what type of problem it is? It is a non-linear. So select the one of the inbuilt algorithm, we'll call it as GRG non-linear, and press solve. The solver automatically generated, found some solution, and it all constraints are optimally satisfied to get the feasible solution, and the answer is here. Click on OK. So this is my answer report. Okay, so what type of algorithm I've used? GRG nonlinear. How much time it took to solve? Here is 0.016 seconds, and the number of iterations it took is 2 iterations. And the objective cell, I am taking it as the 13th cell. The initially, by putting 0 and 0 as my input variables, the function generates the output as 13, and after optimization 2 iterations, it yields to, this is the minimum value. If you see this value, what is the final value you are getting? 1.15463 e power 10 power minus 14. So it will not give you the minimum value as a 0, but it will give you in the form of like a this in this form. Okay, so which yields to, which is the nearest value to this 0. Okay, and similarly these are the initial guesses for my input variables, and after solving this, there's a final value for this is 1.99, so that is 2 and 3. So suppose if I want to do it theoretically, how can I do this? Any problem can be solved by taking a first derivative and set it to 0. So then you can get a system of solutions for this. If you do, you will get two solutions. One is 2 and 3. For that particular output is 0. But the solver is showing the output is 1.5 into 10 to the power of minus 14. So this is almost 0, but it will not show you as a 0. Okay, that is only the change here. So that is a one of the example for non-linear. And then this is the another problem. We'll also call it as a banana function, which is this particular function will always use it to solve to test that particular our algorithm. Suppose if I am writing some algorithm, gray wolf or whatever it is, if I want to test my algorithm, what is the optimization objective function I have to use is some test functions I have to use. So we'll call this function as a Rosenberg function, or we'll, in the other words, we'll also call it as a banana function. Okay, so this is a definition for that. It's subject to, this is a constraint, and in such domain, the limits on that my input variable x is from minus 1.5 to 1.5, and the output is from another variable, this is y, another variable is limits bounds on that is minus 0.5 to 2.5. So if I do the similar procedure, I'll get this solution as at 1 and 1 as a input x and y. So the function generates almost 0 values. So can you note down this problem and can you do this later? I already solved this and I'll show you problem 3. Right. So this is my definition. If you see here, on first initial guess, I have to put these values as 0 and 0. And function I have defined here. What is my function? If you see here, equal to 1 minus x. X is nothing but C5 whole square plus 100 into y. Y is nothing but C6 minus, is it visible? So this is my definition here. Okay, so then I have to press enter. Then I have to define what is my constraint. Here the constraints are x square plus y square minus 2, and it obeys some inequality less than or equal to 0. Right? If I want to solve this, go to data and solver. Right? So before that I have to delete the earlier one. Right. So what is my objective function? So here the objective function is this, and what is the type of problem? Minimization. Select the minimization, and what are the changing variables? I have two variables. Select these two, X and Y cells. So that is C5 and C6. And coming to the constraint, what is the constraints I have? Only one constraint is there on my optimization. So that is this G. The definition for this is this one, less than or equal to already there, and that respective value it has to satisfy this value. Okay, right? So this is my constraint, and this is my anyhow, while looking at this particular problem, this is a non-linear case, right? So click on this solver button, so you will get the output. So this output is showing I'm using GRG nonlinear. It takes some iterations, and this is the values, right? So okay, so after changing this, these are the values to my input, and the corresponding output is this one. So this is my solving in this particular case. Okay, and similarly the next one is multi-objective optimization problem. So here if you see, this particular problem is a non-linear equation, and it doesn't have any constraint, and the search landscape is ranging from -5 to 5. So means that the solution might lies between the -5 to 5. Okay, so here if I want to do this, I'll take my already defined problem. So this is my definition, right? So this is my equation, and the search scape is -5 to 5, right? And these are the feasible solutions, right? So what is multi-objective? Multi-objective is nothing but, earlier till now we have seen 3 problems and it produces only a single solution, right? But here that particular problem is generating 4 solutions. So if the system produces so many outputs, we'll call it as a multi-objective optimization, right? So first step is I have to define my variables. What are the variables here? I have X and Y. So first step is I have to define my initial guesses as 0 and 0. So these are the variables, and if I keep this 0 and 0, my system produces what is the initial objective output? My 11 square plus 7 square, that particular value is 170. If I want to solve this and to get all of these possible solutions, what I have to do? Go to data and click on the solver button, right? So what is my objective function here? So objective function is here, right? 170. So click on this particular cell. That is my objective function. And what type of problem it is? Minimization. Click on that. And what are the input variables I have? So what are the input variables? X and Y. With respect to the initial guesses, I have to drag here. And coming to the constraints, look at the problem. The problem doesn't have any constraint. So simply, and this is a non-linear. Look at this. Okay. So, and coming to this checkbox, if you observe the solutions, so there are some positive variable and negative variable, right? So keep this checkbox, uncheck this, because you might occur the non-negative answers also, variable values also, right? So uncheck this, then click on the solve button. Okay, so click on OK and go to your sheet. You can see the particular one. So what is the right? So for this, I'm saving this 1 second. Right. So this is my problem. So first I started my variables with the initial solution 0 and 0, and after putting this solver into action, so it gives the one of the solution among these four. So what is that solution? First one, that is the variables, if x and y are 3 and 2, the function generates 0. So this is the value I am getting. So how can I get the another solutions also? I have to search in this search landscape. So the landscape here is from where I have to start. I have to, if there is any treasure, if the particular person asks me to search for that particular treasure, and if he give the hint to find that, to dig into that, so that particular hints are nothing but this is a space, search landscape. Okay, so from -5 to 5. So suppose if I take the values are 5, -5 as my initial x value and 5 as my second value, then look at this solver here. So what is my objective? This is my objective. And what is my problem definition? In minimization. And these are the variables I have. And then click on this nonlinear, then solve it. So I have some answer with this. So that is this one, right? So what are the values? It is updated -2.81, 3.13. What is that particular set? This is that set, and the function generates the next one. So how we can expect the solutions in multi-objective optimization is, it depends upon what are your initial guess values. So the first I started with 0, 0. I am getting this first set, that is 3 and 2 are my changing variables. So if I start with -5 and 5, I'm getting the second one. So, suppose if I start with -5 and 5. So -5, and even I'm keeping the second one is also -5. Okay. So now again I'm doing the same procedure. What is my objective function? This one. And what are my changing cells from this to this? And there is no constraints, and click on this. So I don't require this. See here answer. So what are the variables? It is update. It updates this Excel sheet automatically with the corresponding solution. So -3.78, -3.28. So this is my third solution I am arriving. Right. So this is the another one. And similarly, if I want to get the fourth solution, what might be my initial guess for my x and y? So the first one might be 5 and the second one might be -5. Okay. So now we'll also do the same thing. Go to the solver and select my objective function. And this is a minimization problem, and select, and I don't have any constraints, and click on that solve. So what are the, I don't want any answer report, see here. So 1 second. Right. So what are the values we got here? 3.58 and -1.85. So this is the fourth solution I am arriving. Right. So this is the example for multi-objective optimization. If the system generates more than one solution, we'll call it as a multi-objective optimization. That can also possible with the help of the Excel solver. Okay. So now coming to the last slide, the disadvantages of the Excel solver. So here, though it is easy for everyone, without any coding, we can do the optimizations. We can solve any problem in the Excel by using this Excel solver. But there is a limitations too. That is, we can have the limit on the decision variables is only 200, and maximum 100 constraints only we can apply on our problem. Okay. So and whenever there is a multi-objective, if you see that report, it take more than 2 seconds. So earlier While doing the simple linear equation, it takes only 0.016 seconds. But for doing, if the number of constraints goes on increasing, it takes so much of time for doing this optimized solution. So this is a disadvantage of my Excel solver. Any doubts in this? Any doubts in this? Anybody? Anybody? Okay, so we'll move on to the next one. After this, that is MATLAB optimization toolbox. Is my screen visible? Is my screen visible?
Yes, ma'am.
Yeah. So we'll move on to the next one, that is optimization toolbox. So though the MATLAB is a customized version, we have to pay the money for getting the license of this, but there is a online solver also. So for 30 days trial version for MATLAB, we can install whatever the toolboxes we require for our research. We can do it for 30 days. Trial version we can install on our laptops. Okay, so I already sent some link how to install trial versions. So I think everybody already have your MATLAB in your laptops, right? So the first one is MATLAB optimization toolbox. So in this I want to cover how to define an linear programming problem and non-linear, and the basic intention of this optimization in communication is how to do the least square minimization. I'll let you know what is meant by least squares. Okay, so and already we come across the one particular meta heuristic algorithm, call it as GA, we'll call it as genetic algorithm in the last 3 days, right? So how to do this by using these toolboxes. Okay, so these are the 5 topics I want to cover in this MATLAB. So if I have this MATLAB, I'll open my MATLAB parallelly. So this is your, one second, clear. CLC, press enter, it will clear the command window. Bear with me, my system is slow. Right, so this is your command window. If I want to know where this optimization toolbox appear and what are the solvers that we can do and what type of problems we can use this optimization toolbox. If you want to know, go to the command window. After appearing this double arrow, press it as doc. It will open the documentation. It will open the documentation of MATLAB. Right, so the left side there is a list of contents here. Go down and search for optimization toolbox. So here there is a getting started, and go scroll down and go to this about optimization toolbox solvers. So what are the solvers this particular MATLAB is supporting? What type of problems we can do with this? So click on this. These are the particular. Is it visible? I'm maximizing this. Right. So what are the toolbox solvers we have? One is we can do the minimization and we can solve multi-objective optimization and we can solve so many number of equations and also we can do this least squares curve fitting solvers. So these are the different one. If I click on this minimization, what are the problems that can be handled by different set of solvers is listed in this particular page. Okay, so the first one is, so earlier we have seen linear problem and non-linear problem, right? So here there is a different f min b and d. So that is, these are the solver names in the MATLAB. So if there is a bounds on my minimization function, you know, f of x is my objective function and the definition for my objective is minimization. So for that, what are the bounds I'm applying? The lower bound should be less than x less than upper bound. So if this is a scenario of my optimization problem definition, then I have to use this f min b and d solver. And similarly, it shows that if I don't have any bounds on my input function, then I can use, if there is no constraints at all, then I can use either f min UNC, that is unconstrained, or I can go with respect to f min search. So the only difference between these two solver is f min UNC can solve only single objective problems, but f min search can go with respect to multi-objective without any constraints. So that is the difference between these two. And if I have a set of linear equations, I can solve this by means of linprog, LINPROG. So that is one thing. And the next one, if I have a quadratic expression, I can use this quadprog. And if I have any minimization function, there is a special default one, that is f min con, and this is the equation. And for multi-objective also we have so many, and for equation solving. So suppose if I have n equations and n variables, and it is in the form of like if I take a wireless communication as an example, so if I take any AWGN channel, so how the system can be defined? Y is equivalent to, so if the input is x and the particular input is the impact of that particular AWGN noise will appear on my input. So the system can be written as y equal to x plus n. So this is a wireless communication under no fading environment. So suppose if I take it as a fading environment where that particular system is treated as some filter, then the filter impulse response is h, will call that h as a channel, then that expression can be written as y is equal to h into x plus n. Right? So that is a linear equation. If I want to solve that particular h value, then I can go with respect to set of linear equations. So that is, if it is in the form of c into x is equal to d, then I can use this ML divide. So everybody we will see the least square, if that particular system of equations is in the form of x in c into x is equal to d, like our normal AWGN channel equation, then we can simply use ML divide approach. ML divide is nothing but it is a backslash operator. If you click, you can come to know that what is ML divide. It is a backslash. So if my system is representing in the form of AX equal to B, then the particular channel can be estimated by using ML divide. So this is a simple one, how to calculate the channel in a wireless environment. Okay, so x is equal to a backslash b, or there is a inbuilt command, we'll call it as a ML divide. Okay, so this is one of the equation how to solve your system of linear equation. And if that particular system of linear equations are having constraints, so then how to do that? So and if that particular system is equal to 0, then what is the solver you have to use? In general, fsolve is a inbuilt command, use it to solve any number of equations. And this is for if there is any particular curve is there, and if I want to fit all my data set points on that particular curve, then I have to go with respect to least squares. So in wireless communication, for solving for designing any channel estimation, we will do least squares estimation. Right. So that particular the particular channel is in the form of formulated in this particular structure. So in such a case, as I told you, I can simply use the MLD word to estimate my channel. And if that particular one is having some constraint that all my channel variables are greater than or equal to 0, then I can use this particular inbuilt command, that is LSQ stands for least square and non-negative. So all my H values or channel values, channel parameters are positive values. So then I have to use this particular inbuilt solver. Okay, so this is a particular table that is very useful. Which solver I have to use for which type of questions. So based on this, so how to go with respect to this? Go to the doc and go with respect to optimization toolbox. There you can come to know what are the optimization toolbox solvers under the getting started. Right? In that, if you click on this, you can come to know this particular 2 pages data. Okay, so this is about what are the type of solvers you have. So then coming to my PPT, right? So this is the PPT. In this slide, I shown the same thing, and this is the PDF. If I click this PDF, that PDF with the set of solvers, definition of that particular frame structure of your optimization, everything will be displayed. Okay, so then out of this, all these particular 2 pages table in this PDF, generally we'll use this following solvers. One is fmin bnd. So if you are having some set of bonds, this is the solver. And as I told you earlier, these are the respective definition for commonly used solvers. So now we will do one problem with respect to fmin con. So there are here 2 ways available. One is you can use the syntax, or you can use the optimization toolbox, which is GUI based solver. Okay, graphical user interface. So suppose if you know what is that solver you are using and what is the definition for that solver, if you know everything, it is very simple to write the code in the MATLAB. That is one way. That is the first one. And if you know that, if you don't know that programming steps, how to write it in the MATLAB, then simply you can go to use this graphical user interface based solver. Okay, so this is practically this is what we have to do, either this case or this case. But before that, how to solve any equation. So on the second day, Rajiv sir told about some set of matrices, how to solve by rank based or the row based minimization or column based. So that is Newton-Raphson method he explained, right? So if there is a simple equation, how to minimize that? So generally what we will do, if I want to get either minimization or maximization, first I have to apply the gradient for that. Gradient is nothing but the first order derivative. So if I do this dy by dx and set it to 0, I can know what is my particular variable value at which my system is going to be feasible. Okay, so if I do this dy by dx, so x square is nothing but 2x plus 3x is nothing but 3. If I set it to 0, 2x is equal to minus 3, x is equal to minus 1.5. If I substitute in this equation, what is my y value? Y is nothing but minus 4.25. So the same output I am expecting by using this fmin con solver. So this is a solver name. So what is this solver says that whenever you are having a problem to minimization problems, so read the problem here, minimize. So whenever you are having minimization problem, and that too if you have any starting values, if you have any bounds on your constraints on your particular minimization problem, you can go directly with this default solver, call it as fmin con. Okay, so first I'll go with respect to the syntax version, then we will use what is your GUI based version. Okay, so in syntax version, first The next slide is, this is your syntax of your fmin_con. What are the arguments it is expecting? First, you should know what is your function, and x0 is your initial guess. A is nothing but your constrained left hand side. For that, I'll show you what is this fmin_con in a MATLAB. Right, this is my minimization fmin_con, where it is, this is my fmin_con, right? So how the description of this? I have to minimize one optimization function such that it is having some set of linear constraints and also non-linear constraints. So C of x less than or equal to 0, that is a non-linear, inequality constraints, and C equal to of x, CEQ is nothing but the function C equality constraint is equal to 0. And how the constraint should be? It should be in this form. What is the form here? Ax less than or equal to b. What is A here? Left hand side of your constraint, and b is your right hand side of your constraint. Okay, and if I keep this less than or equal to, then the constraint is an inequality constraint. And if I want to convert it into equality constraint, then A should be equal to AEQ and B should be equal to BEQ, and less than or equal to should be replaced by equal to condition. And this will call it as a bounds to my input variable x. Okay, so if this is a frame structure of my problem, then I can use the fmin_con by using any of this syntax. So all syntax says that you have to define your objective function, then you have to give the initial guesses like x0, then what is your left hand side of your constraint, that is capital A matrix, and small b matrix on the right hand side of your constraint, and what is your A equality constraint matrix, B equality constraint, LB is nothing but your lower bound, and UB is your upper bound, and if you have any options you can go with respect to that. Okay, so this is your fmin_con. So if I want to solve this particular problem, so right, so the first one is y is equal to x square plus 3x minus 2. So I know. So here I came to know that this is my syntaxed version of solving this particular equation using MATLAB, right? So first there are two rules in solving syntax version. So the first rule here is I have to create two functions. So the first function is my objective function and the second function is my constraints. So like what we did in case of the Excel solver, I created two tables, right? So the first table, it decides about what is my function. And the previous to that, I defined what are the variables I have. Then I defined one table for my objective function. Then I've created one table for my constraint, right? In the similar manner, in MATLAB, we have to create two functions separately. What is your objective function? And then what is your constraint function? So what is your, I'll do it in parallelly with MATLAB. Okay, I'm selecting the new window. Right. So how to write a function in the MATLAB? So if I take any, one second. Right. Is it visible? Right. This is my function. How to write this in MATLAB? So MATLAB, while defining any function, you have to write the syntax in this manner. Function. Then what is the name of that? Function name is equal to, here the exact calling function name you have to give. So suppose if I'm writing it as my objective function or the particular cost function, any name you can give. Okay. Minus So it's not minus, it is underscore cost function of what are my arguments to define my function. So this is function. And you have to write a system of equations in that, and you have to write end statement, and then you have to save it. This is a procedure to define any function. Okay, so this is your function name and these are the arguments. So within that function, what you have to write? How your f is related to your x. So that set of equations you have to write. And every function should end by end statement. And while saving any function, whatever the name you have given here, that will automatically appear in MATLAB. You have to save like that only. You should not change that saving name. Okay, so for functions, whatever the name you are writing here, that will give after pressing the save button, it will give automatically. You have to save it on a particular folder. And one more thing, whatever the function you are writing, that should be in your current folder. So suppose while calling that particular function in separate another file, so if it is not there in your current folder, it won't execute. So that is the point you have to remember. Okay. So now coming to this MATLAB. Right. So that particular question, I'll do it here. So first I'm writing function. I have to give space. I am defining that problem as f, which is equal to what I'm doing is I want to write something like obj objective underscore fn. Okay, so this is the name I'm giving within bracket. What are the variable name for my question? That is x. Okay, so either you can give it as f, or in the question I'm mentioning it as y equal to something, right? So I'm writing like this. So then press enter, and how this y related to x you have to write here. So what is the given thing here? Y is equal to, what is the question? Question is y is equal to x square plus 3x plus 2. So I have to write the same statement here. Right, y is equal to x square. X, while doing the square, you have to use the dot operator, plus 3 into x square plus 3x minus 2. And then you have to press enter. Your function is n here, right? So now if I want to save this, I have to go to save button. Go to save button. So if you press this save button, it will show you what is the name you have given for your function. It will automatically appear in this. Okay, so just save it. Right. Then what is the another function you have to create? Another function here is it's not going, moving my slide. Okay, I'll use my hand. Once again, my mouse is not working.
Okay. So if I want to write the another function, go to the new file. New file is okay. I'll write in this only. It's very slow. Right. So for defining any constraint, I want two values. One is what is its equality and what is that are the outputs I want from my file. And while defining this, I have to give some name for my constraint function. So let me write this as CANST_1, and this is in the form of my x as my argument. And in this particular case, I don't have any constraints, even though I have to mention this as empty matrices. Okay, so CEQ, again it is equal to empty matrices. Then I have to end it. So if I want to save this, automatically this will save in the form of the function name itself, that is CANST_1. Okay, so now if I go to this command window and type what are my output of this. Okay, so go to the command window. After defining these two definitions, go to the command window. Right. Go to the command window or any other editor window and you have to give the initial guess value. So what is the initial guess value? You have to start any experiment with some random value. So it is not fixed with the 2 value. I've just given the value as 2 here, and then you have to write the syntax of that fminCon. So fminCon is nothing but it has, first you have to define that particular function. So here what is your function? Function here is at the rate of, while calling any function you can use at the rate of x. So at the rate of x, what is your function name? So here it's not cost function, so I've given it as objective obj_fn, right? So that value you have to write, comma, initial guess. So what is the variable you have used for initial guess? Either x0 or initial guess, that you have to write. And in this current problem, I don't have any C values, that is what is that constraint equality and inequality constraints, and even I don't have any C, I don't have. And if you observe that particular PPT, and observe that particular syntax, I require A value, then B value, then A equivalent, B equivalent, and then lower bound, upper bound. All these values I don't have from my problem definition. So I have to keep it as empty matrices, and followed by what is your nonlinear, what is your constraint. So the constraint you already defined it as a function. So while calling that particular one, you have to use at the rate of x and then followed by what is the name you have given. So if you run that, you will get what is your output in that command window. Okay. Once again, and right, it's not working properly. Right. So what is your command window here? Output of this. So go to the command window and see the output. The output is in the form of this. Whatever the values of that particular objective function. And similarly, so that is an example for single variable objective minimization. So I have on the right side only one variable, that is only x, and by using fminCon, how can we do that? Right? So suppose if I want to do the same thing using the GUI based, how we can do? We can see it in the coming slides. Okay. So first, before that, we will go with respect to the second problem, that is two variable minimization. So suppose if the question is like this, f of x comma y is equal to x square plus y square plus 2y plus 8y. So first step is what we have to do? We have to separately create two functions. So go to this and write a function. So what is the function here? Function, as it is, you have to write function. Then what is that value? F, and here is equal to what is your objective function. So here I am writing this objective function as obj underscore fn underscore 1. So this is my name I have given, and what are the variables it is having? X here. So though it is having, instead of representing two variables in the MATLAB, I can use the same variable, and the particular elements in that variable I can show as a differently. Right? So means that instead of writing here x comma y as the arguments I'm passing to that function, I can write it as simply x, and while defining that particular function, I can represent x and y as the elements of capital X vector, like x of 1 and x of 2. In such a way we can do in the MATLAB. Okay, so what is your function here? So the function given here is, I'll write this. So that is f is equal to x square plus y square plus 2x plus 8y. So we'll write the same function in the MATLAB. So how to write this? F is equal to x square plus y square plus 2 into x plus 8 into y. This is my definition of my function. Then every function should end by n, right? And if I save this, it will give the whatever the function name I mentioned, it will give the same thing, and this is my this thing, right? So suppose if I want to create the another function for constraints. So but looking at this particular problem, is it is having any constraints here? No, but even then we have to create one function for constraints. So let me create one more function. How the function should be? Constraint function. It has two output values. One is constraint C, comma C equivalent, C eq should be equal to what is your constraint function name. So I'm calling it as constraint. And what are the arguments I have to pass? Only I'm treating here x as my vector of elements, some number of elements, where that elements might be multivariable function vector. Okay, so here I don't have any constraints, so simply I can make it as C is an empty matrix, and similarly C eq is my empty matrix, and the function should end by n. Okay, and if I save this, it will give as a constraint underscore 1, right? And there are two ways. Directly I can go with respect to command window and type this, or I can create one more editor window and I can write it as initial guess as my x naught, which is equal to what is the x, some problems they will give what might be your initial guesses. So here the initial guess, it is given, I took it as a 4, 7.
So because there are two variables, I am representing this initial guess. I'll write the same thing, initial underscore guess underscore guess, which is equivalent to, because I have two variables, I have to give two initial values for my elements of my x vector. So that is 4 and 7. 4 is for my x1 in that vector and 7 is for x2 in that vector. So then simply I have to write what is the syntax of my fmincon. So what is the syntax of my fmincon? It produces the two outputs. One is what is the optimum values of my x. I can call it as x underscore opt. And what is my final, after putting these values, what is my expected result of my function evaluation output. Okay, so this is my output of my function. So what type of solver I'm using? fmincon. What is the syntax of that? First I have to write it as a what is my function. So if I keep cursor here, it will show you what are the arguments I have to pass here. First one is function. So what is the function I have used just now to define my this thing? Obj underscore fn underscore 1. So this is my function. So after that, what we have to do? So I have to write what is my initial guess. Initial, this is a variable I have used to represent my initial guess for both of the variables, initial guess. So then what are my constraints in this? I don't have any constraints. So I have to make, what is the syntax of that? So first you have to remember that particular syntax. Syntax is after initial guess, I have to give what is the vector for that left hand side of that constraint, that is ax is less than b. We have seen the definition, right? A is a vector on the left hand side of my constraint and b is a vector on my right hand side of my constraint. So and a equal to b equal to are my equality constraints. LB and UB are my lower bound and upper bound. So if I want to represent this, because we don't have any left hand side of that expression and right hand side of our expression and equality constraint, inequality constraint, lower bound and upper bound. For all that, I kept 6 empty matrices. After that, I have to mention the what is the constraint function I've used. So what is the constraint function I have used? Constraint underscore 1, right? Constraint underscore 1. But there is a mistake in this. Can anyone guess it? While mentioning or while calling any function, I have to use at the rate. And similarly, for the another function, I have to create at the rate. So once it is done, then I have to run this particular program. So this is a this is not a function program, so it will ask you to write any file name for that. So you can write it as main underscore ex, okay, and save it, and you can run that particular value. Right? So it is having some error. Objective function is not clear, error in that. So what is that? Right. So these are all, we'll call it as a x square is nothing but element multiplication power. I have to keep these values. Right. Then run my main function. No need of running this functions here. So just directly we can run my main function. It will give you, it will run your main function. Okay. So it is running that. And initial values it is taking. And objective function in line number 2. So what is the mistake I did? So right.
Now you go to this main function and run it. Main function, is there any? Right. Yeah. Yes, ma'am. Here, while writing this objective function at the rate, and also we have to keep within bracket what is that argument we are passing, that whatever the function, right? So that we have to keep here. And similarly for constraint also within bracket x. So then you have to save it and then run. Initial objective. Initial guess I have given. The same thing I am representing in this MATLAB also. Maybe spelling mistake. Initial guess.
I think at the rate x, ma'am. X.
At the rate of x. No, ma'am. So let me try that also. No, might be 1 second. Objective function. And save it. And similarly constraint also. And save this and go to main function. So main function, so we have to give the initial guess. And we have to write the function name, right? And then save this. Now run, we will run this. It's running in this command window. It's showing. It will take some time to get the output because it has to undergo so many number of iterations. Right. So for the values of x is equal to -1 and -4, the function is generating the objective output is -17. So this is this. There might be some spelling mistakes in my previous script. Okay, so for that it is fmin can't work like this. Okay, so this is your way of doing by using the syntax. Suppose if I want to do this graphical user interface, so in the command window, everyone please type optim tool and then press enter. It will ask you whether you want to use the live editor or you want to continue with that particular toolbox. So you have to go with respect to continue with the optim tool. So this is a solver. Whatever the solvers I have shown you earlier, all these solvers appear in this scroll down button. So the first one is for
multi-objective goal attainment. So this is global optimization algorithm. So then fmin bound, and then fmin con, fmin max, fmin search, whatever the table I've shown you, everything is clear in the scroll down button. So in our case, this is a fmin con solver, and there is an algorithm, any algorithm you can choose it. And here, while writing this, you have to call your objective function. Already I used the objective function as, what is my objective function here? obj underscore fn underscore 1. So I have to call this in this GUI. So how to call this? At the rate of, what is that? obj underscore fn underscore 1. So this is my objective function. And what is my constraint function? Constraint underscore 1. So here there is a chance here, underscore constraint underscore 1. So this is my constraint function which I have defined in this editor, right? So then I don't have anything here. Like all these matrices, I kept it as empty matrices. So no need of giving this. So that is A matrix is not there, B is not there. But one thing we have to do, that is starting point. So what is the starting guess I've given? 4 and 7. So 4 space 7. Then you have to choose your start your particular one, and here it will give you an option to select what type of stopping criteria you require, and what is your approximated derivative values if you want to keep it on your command window, or what are the, if you want to change the algorithm settings you can do, and finally if you want to plot, you can plot your relation between your f and whatever the input variables. So if I just press start here, if I just press start here, so you can see this optimization is running and there is an error in the optimization. So error might be at the function of x, and similarly and here also I can write this as system of equation of x here. Okay, so you can check it here also. I have shown in this case. So you have to define that particular function, and also you have to write what is the starting point here, and also you have to mention if there is any bounds on your system of equations. You have to write that A matrix and B matrix, then you have to start that particular problem solution, solving that particular problem. Okay, so here also I did the same thing. So fmin con active set, and if you want you can change this also, and this is my objective function, and this is my constraint function, where if I want to create any lower bound or upper bound, I can do this. Maybe this name of that particular function, I'll give this name. One second. At the rate of, my function is this, and similarly for constraints also I'll give this name. At the rate of of my constraint. Right, now it is running. Right, I'll clear this previous results and I'll start this. Optimization is running and there is error in the starting guesses. So if I change these guess values, you will come to know what is the optimized value. So this is a GUI based. You can use this for all the solvers. Okay, and similarly I have given for a 2 variable minimization, this is a syntax based, and normally for optimization problems will be in this format. So if they give some initial point and if they give some objective value, and by using some solver we have to do. Okay, so if there is a nonlinear function like y equal to square root of x, and if they give at particular point from 4 comma 0, and I have to find what is the minimum point on that particular graph so that the distance is very shortest. Okay, if I want to find out the distance, usually in mathematics how will you solve here is this is x1 y1 and this is x2 y2, and the distance between these two is x2 minus x1 whole square plus y2 minus y1, and then after that if I apply the first order derivative and set it to 0, I may get what is my x and y values. So this is the theoretically how I can solve that particular equation, nonlinear equation. So in the MATLAB, what we have to do is, so we can go with respect to constant underscore function. So it is a, I've already created one. I'll show you constant underscore function 3. This is a function where it's opening. 1 second. Right. So this is a y equal to square root of x. So this is a way we have to define our constant underscore function. So similarly, we have to go with respect to define the another function to define your constraints. Constraints is should be, so there is no constraints in my y equal to square root of x problem, nonlinear function. So I've just defined in the function form. Right. So then if I go with respect to any other window to find out what is my output of this fmin_con. So what we have to do? First I have to write the initial guess, then I have to give what is my fmin_con function. Fmin_con, if I mean, yeah, I have written this at the rate of x, what is my function name, comma initial guess, and if I don't have any other vectors, I have to keep it as empty matrices, and then I have to call my constraint matrix. So then if I run this, it is running in this command window, and if I want to know what is my x parameter value, just press x and enter. So this is my x value, and similarly the output, another output is fval. So if I press it on that command window, you can come to know this is 8.88 into 10 to the power of minus 7. So these are the values, final minimum value for my nonlinear expression. So in the same way, we have to do it with respect to that GUI based also. So GUI, again, I have to go to Optim tool, press enter. So here only the thing is you have to define what is your objective and what is your starting point, and also what is your constraints function. Okay, so the constraint objective function here is, what is the objective function we are using? Cost underscore function, right? So that value I am giving here in that tool at the rate of this function. And what is my initial value? Initial value is 4, and I don't have anything here. And what is my objective function? Objective function is constraint under constraints underscore 3. So that particular same name I'm copying, because spelling mistakes will give you an error. It will throw an error. So I have to give here this. Then if I want to add any plot functions, I can write here as fplot or whatever it is for my input and output function. So fplot is one of the plotting function for these functions, and then I can go with respect to the start button. So it will give you what is your final output value. Okay, so this is the manner you can go with respect to the GUI based version. So I've given so many. I'll share this PPT to you. You can just go. So this is GA based version. So in the same tool, there is another, instead of this fminCon, if I want to solve the same problem with respect to GA, the last option here is GA is there, genetic algorithm. Only we have to select that particular algorithm type, then keep everything function name as it is, and then you can press this start button to get what is the value you are getting with respect to this GA algorithm. So like this, if you are having a system of linear expression, so this is linprog. Okay, so these are the this is GA based output you are getting. So, and this is your system of linear expressions. If I want to solve this, I can select this particular solver name as particular linprog, and then select what is that function, input function, and what are the constraints I have, put it in terms of a matrix. So then I have to press the start button. Okay, and this is the fmin bound function. I can use the similar way. Am I audible? Right. Sorry for the disturbance. So these are the various solvers you can go with respect to all. So then coming to the last one, least squares. So suppose if I have the system of equations like this, I have to define the corresponding vectors in such a way that what are my constraints. On the left side we'll call it as a function, on the right side we'll call it as a b. Ax is equal to b, right? For that, if there is any equality constraints, I have to write it, and if there is no equality constraints, I have to put it as a empty matrices, right? In this particular function, the constraint here is x1 plus 2x2 plus 4x3 is equal to 7. Equal to says that it is a equality constraint. So I have to write it as a equal to is nothing but equal to left hand side. What is that? Elements, coefficients I have 1, 2 and 4. So that is equality constraints coefficients. And similarly, what is B equivalent to? B equal to BEQ is nothing but right hand side of my equality expression, which is only 7, right? So if I define the same thing on that particular tool, we will get this particular values. What is the particular optimization solution for my particular function? So this is, I have to select, because it is a LSQ linear equation. I have to select that particular solver as LSQ LIN, and then I have to write what is my equality vector and non BEQ value, and then I have to start that particular value session, right? So then I'll get what are my results from that particular variables for the changing cells and the corresponding F value. Okay, so and these are the references you have to go with respect to this MATLAB, and there is a self-paced online course for doing this MATLAB tool, MATLAB in optimization techniques. You can register that, which is a free in MATLAB, and you can gain some of the knowledge related to what are the different type of solvers available in MATLAB. So this is a self-based online course available in mathworks.com. And also you came to know with this particular PDF what are the different type of handlers available. So this is with respect to MATLAB optimization toolboxes. Any doubts in this? Any doubts in this? Anybody? Anybody are having any doubts here?
Madam,
Yes, sir.
like I
Yes,
have
ma'am.
one doubt.
Yeah.
Like what are the examples that you have done? X
Yeah.
cube plus some 2x plus 3, something you have taken. So instead of only one value, let me take that equation as ax square plus c.
Okay.
Then a value I'm changing, like I have values of different values of a.
Ax square plus c is nothing but you are talking about the constraint, ma'am?
Objective function.
Objective function. Okay.
Yes, ma'am. If my means like you can take like as a 2x plus 3 or something also, but it is for one value of a and c. If I want like let me say like in our communications when we are talking about channels, and if the channel is keep on changing, the value of a is now in a vector.
Right.
Multiple values you will be getting it, or else a can be taken it as a transmitting power. The transmitter power, if I'm changing it, your objective function is going to change. Yes, ma'am.
Correct. Yes, ma'am.
So if my a is not single point value, if my a is of some n number of values, is there any procedure to find out the minimization value by using fmincon? Because when I was trying, like it is executing for only single value.
Right, ma'am. Right. Already I shared that particular PPT to you. One second, I'll show it again. That
Yes,
PPT says that fmincon is for only single objective optimization. So for
okay.
multi-objective,
We
you have
have
to select another solver. I'll show that PPT PDF.
okay.
So
Okay.
this is the PDF. This PDF is through that MATLAB also. MATLAB, it is available in the MATLAB. fmincon is one. It solves only the minimization problem, that too for single objective optimization. So
That
if I
is good.
have
If
multiple
my
one, I have to select fmin search on the first slide itself. I told
means like
fmin
the only the value of a constant I want to change. Objective function is not changing. Of course, you are getting for n different values, you will get n different objectives.
Yes. So for that, it is, we'll call it as a multi-objective. You have to select the different solver.
Okay. Now, what is that, ma'am? May I know?
Fmin search, ma'am.
F min
I
search.
think my screen I'm not sharing. I'll show you.
Okay, ma'am. Otherwise, you can share, ma'am. No problem.
Yeah. So is my screen visible, ma'am? So this is F min search. So this
Okay.
is unconstrained for multi-objective search.
If it is constraint is there?
If the constraint is there, then there is another constraint. We can keep here this F min con with the constraint itself. For multi-objective, we have to go with respect to F goal attain.
F?
Goal attain. Ma'am, is my screen visible?
Yes, ma'am, but it is the font size is too small, so I cannot see that.
So this is multi-objective for F
Okay.
min max or F min
F
goal
goal
attain.
attain.
Goal attain. So you
Okay.
can go with respect to that. So F min
Okay, ma'am.
search is nothing but another one for unconstrained if we are having multi-objectives. Sorry,
Yes.
multiple
Okay.
multi-objective, multiple outputs from that.
Multi-objective without any constraint.
Right, ma'am.
Okay. F min goal attain is for multi-constraint with object
For multiple
constraint.
objective solver.
Okay.
Multi-objective solver.
Multi-objective with constraint.
Right.
Okay.
With
Okay.
it also
Thank you
here
very
the definition is also here. So there are the different constraints here. This CQ equal to 0. So means that this solver can also attain useful for constraint with constraint.
Okay.
With the constraints. So for
Okay.
if you don't have constraints also you can use this solver. So the solver mainly for with constraint we can use for multi-objective unconstrained also same solver, ma'am. I did that.
Yes, understood. Like as you defined it as a without any constraint as an empty in the body.
Right.
Like,
Right.
yes.
So
Okay.
while defining the function itself, you can keep that C of C is equal to something like empty matrix, and CQ as if you don't have, you can keep it as an empty matrix. Then you can define like. Okay, ma'am.
Thank you, ma'am. Thank you very much.
Yeah, ma'am. Thank you. Any other questions? So actually I have less time, but actually in my schedule I have GNU Octave also how to do the optimization, and if time, I mean in the future if any resource person is not available, we can discuss that also. As of now, I covered what is Excel solver and also how to do the non-linear and linear problems with respect to Excel solver, and how to do this syntax version of the MATLAB for optimization problems in case of linear and non-linear. If any doubts, you can ask. Otherwise, we'll conclude this because next session is on Q. Anybody is having any doubts? If no doubts, I request Bhavna ma'am to conclude, Vaishnavi ma'am to conclude.
For today's session, ma'am, we understood about classification of optimization algorithms, NFL theorem, how to use Excel solver, and in that how to solve linear and non-linear, and even multi-objective optimization problem. We understood. We got a hands-on experience. Thank you so much for wonderful.
Thank you, ma'am. Thank you all for attending my session, and we'll meet at exactly 2:10. Sorry for inconvenience. Because it is a lab session, we have to simultaneously do the practice. So I took much of time in this. Sorry for that. And can you please come fast around 2:10? I'll request the another speaker to wait for 10 minutes in the lobby. Please excuse me for today. We'll meet at exactly 2:10, ma'am. Please come and join. So next session is by Balvinder Singh sir from NITTR, which is an application of this particle swarm optimization. Very interesting topic. And whatever the theory we have learned so far, it is only the definitions or whatever it is. But what in terms of applications from today onwards till the last day, the different type of applications we are coming to know about these applications in communication engineering, please do attend at sharp 2:10 p.m. Thank you.